Okay, now I'm trying to figure out what vectors are in vector spaces, and it's a bit abstract, so let me try to find some kind of physical equivalent. And so, that's a mistake.
Well, I don't know. Maybe examples are useful. Maybe if you're weak,
Wow.
you need examples.
I didn't expect this to get called weak. Well, here we are.
No, I'm very weak.
No, it's okay. You don't
Sometimes
have
one
to.
of my best pieces of work was working out an example.
Okay.
There was some crazy p-adic object that I wanted to understand, and I thought, okay, damn it, I'm going to work out an example.
Oh, wow. Was it difficult to find an example?
I mean, yeah, it was a lot of
Yes, it
was a lot of work. There was this mathematical object, and I knew that it was defined by an equation, and I figured that I wanted to work out what this equation, like, there was a mathematical object, for each prime number there was an object, and I wanted to understand these objects.
Has the ability to generate ideas over the years, has that, do you feel that ability has strengthened, deteriorated? Has that seen any change?
Oh, what a weird question.
Yeah, you're welcome.
The thing that I really feel has clearly deteriorated is my ability.
I roll up to the reception of the Imperial College in London, and there I meet Kevin Buzzard. Kevin is a professor of pure mathematics there, and when I meet him, he's wearing these beautiful rainbow pants and these big, heavy rainbow shoes, and I think this is going to be a crazy ride, and it ends up being exactly that. Kevin is a genuine visionary of the math world. He is on a mission to build a computer that can prove mathematics. He's literally spearheading the movement of what it means to digitize mathematics itself. Kevin is remarkable and also extremely happy, which might come as a surprise to those watching. But withstanding, this was an amazing conversation. I feel very privileged, and I hope you enjoy this conversation with Professor Kevin Buzzard. For an opening question, what I actually want to start with is I want to go straight for the jugular. I want to essentially go straight to the belly of the beast here. And the way that I want to do it is I want to use a weapon in the form of a quote. And it's a quote by Bertrand Russell. And it quickly became one of my favorite quotes. There are a lot of reasons as to why this quote is so good and why I enjoy it. And I know this is a famous quote. This is not going to be the first time you've heard the quote, but for a little bit of additional context as to why I enjoy this quote so much, it's I think I had the experience that a lot of people do, which is growing up, math is semi-arbitrary, semi-meaningless. It doesn't really mean anything. It's, you have to do your times table because that's what it is, and it never really grows beyond that. So math just becomes another subject in the vast sea of subjects you're kind of forced to do, and it never really evolves beyond that. So I think that was largely my experience. So there's a version where when I hear that quote as that previous version of me, I hear the quote and I go, this guy is literally insane. I go, there's no way this is actually true. And then I had the great privilege of recently being exposed to math again. I kind of get to go into the mathematical arena from scratch and go, wait, like what is this thing actually? Let me try to really figure out why this thing even exists to begin with. And so that second version of me reads the quote and goes, I can kind of see what's happening here. So like there's a very strict line being drawn between the two versions of me, but it's fundamentally the same quote. So I'm actually just going to read the quote to you now. And again, I'm sure you've heard it, but it goes, there was a footpath leading across fields to New Southgate. And I used to go there alone to watch the sunset and contemplate suicide. I did not, however, commit suicide because I wished to know more of mathematics. That's such a... I can genuinely understand why people who haven't had much of an exposure with math would read that and go, this guy's a lunatic. Like, how could you ever say that? But it seems to be genuinely true, of course. And obviously the person who says that Russell is somebody we have to take seriously, a very legendary figure. So I guess the first question is just, can you elaborate on what the hell that thing is? Like imagine somebody saying, I thought about ending it all, but I wanted to know more about social studies. You go, yeah, that's not obviously going to be real, but here it actually seems like, what is it about math that kind of has that draw? I mean, that's such an intense statement.
Yeah, I mean, it's the beauty, right? That's what maths is going on in a different place, right? Maths models our universe, but what's really going on is that maths is happening in a different place, maybe people call it the Platonic universe or whatever. And in that Platonic universe is a perfect place. That's where all the stuff exists, like perfect spheres. There's no such thing as a sphere, right? There's a ball, there's a billiard ball or whatever, but it's not a perfect sphere, because when you zoom in, it's just like atoms and stuff and dust. But, in the abstract universe, there are there's perfect circles, right? No perfect circle can exist.
Yeah.
Because paper is thick, right? Very, very thin, but non-zero. A perfect circle is literally has zero thickness. So all this stuff exists in this perfect universe, and once you begin to understand what's going on in there, you're just like, this is a place worthy of looking around and exploring. And I think if you fall in love with that place, as I think many mathematicians do, then if you can see that beauty, and certainly not everyone can, but if you can see that beauty, then that is a place where you want to look around further.
That's amazing. Maybe actually this segues nicely into another question I had, which was, generally when I try to learn something, I have like a twofold approach. They kind of combine into the same thing, but I try to go at it from the route of saying, how do I derive this? Like a little bit the Feynman, if I can't invent it, create it, whatever, I don't understand it. And I combine it with a very simple question, which is, why does this thing exist to begin with? And for all of human-created knowledge, which I think is largely what you'll get exposed to in business, right? You need to learn, like even software principles, even, data transformations with SQL, even accounting, whatever. Like they're all fundamentally human invented concepts. So if I want to know what is depreciation, I just go, why does this thing exist to begin with? And I'll get a nice problem that says, hey, if you buy an asset, that's going to be relevant for like 10 years, you need to figure out how to distribute that value basically. Okay, great, I have depreciation, and I can do that with basically all of the other concepts. But then I get to math and I go, why is this thing so different? Like I experience more friction than I thought I would. And then I go, why does the Pythagorean theorem exist? Which I suppose most people have some familiarity with. And then I go, well, it allows you to find, the last side of a right triangle, whatever, if you know the two other sides. I go, okay, yeah, but like why? Like why does it doesn't feel like enough. It feels insufficient. And then you go, well, we can mathematically prove it. We can start with a series of axioms and we can kind of we can deductively work our way to prove that this thing is actually real. But then I go, okay, but like why is it c squared? Why not c squared minus 1? Why not like very close to c squared, but it's not actually c squared, but like why is it actually that? So and with the depreciation example, I can essentially engineer my own solution. I can say, you know what, whatever depreciation tools you have now, I think that's silly. I think this is a better way to solve that problem. I can't, change the Pythagorean. I can't, say, I actually think this is a better way to do it. I can maybe change notation or whatever. But like the thing itself is very strange. Like that dichotomy is something I don't run into when I'm learning any type of like human field, etc. There it's very easy to just couple the things. But with math, I don't know, maybe it's your point about the Platonic realm. I just have to see it for what it is. It's not, nobody chose this thing to be, but can you kind of touch on that? Like this thing of learning math when it's difficult for me to deal with the why does it exist question compared to like all of the other normal human invented stuff.
Right, but it's going on in a different place, right? Mm-hmm. This Platonic realm, like the real universe is just governed by laws that we don't quite understand, but we have good approximations to, and there's a certain amount of noise there. The Platonic realm is very different because there's the axioms of math, and they just describe it completely, and there we have it, and so because we understand the laws perfectly, there are then sort of absolute truths that you can't argue. The Pythagorean theorem is just an absolute truth.
Yeah.
Right. It came out the way it came out, and it is an astoundingly beautiful result. I mean, it is kind of crazy that a squared add b squared is c squared, but Pythagoras doesn't even in Euclid. It doesn't even. There's no mention of squares. It's not even a question about numbers. Right. In the book, it's completely geometric. They literally draw the squares. They don't. There's no numbers. We say it's a squared at b squared is c squared, but there's no numbers even in the original proof. It's a geometric statement, and it just says that this square is equal to these squares, and then you have to look at the beginning of the book to find out what they mean by equal. And what they mean by equal is that you can chop these small squares up into pieces and rearrange them to make this big square. So it's sort of everything is very, very, even the concept of what it means for these things to be equal is very, very carefully written down. But that's just the nature of what's going on in that place. And if you're a certain kind of person, you don't get that, or you don't want, if you're not interested in that kind of world, if you don't like I'm autistic, and I really like the black and whiteness of mathematics. Everything is very clear and well defined. And a lot of people, either they're not uncomfortable with that, or they understand that the real world isn't like it. Took me a long time to realize that the real world was not like that, right?
Yeah.
So I'm coming at it from a completely different place. I'm sort of wrestling with the real world rather than you're complaining about the Platonic world and saying, why is it like that? It's like, that's how it should be. That's how it should be. Everything should be ordered. That'd be great. And you work it out, and at the end of it, you've got a rock hard, you've got this solid proof. There it is in book 1 of Euclid, the last but one theorem in book 1 of Euclid. And there's a proof, and you can't ask why. It's just like, we've just explained why. It just follows from the axioms. And anything you want to know the meaning of, it's there. We're showing that some stuff implies some other stuff, just using the rules of logic. And you can attempt to assign meaning to it, but in some sense, if you explain that to a computer program, the computer program would never even see a triangle.
Yeah,
right?
yeah.
It would just be some way of explaining the triangle in a bunch of computer code. So even the geometry is gone now, and it's just some abstract system says that some equation is true. There's something really sort of fundamental about it. You're not open to interpretation.
Yeah. And I think maybe that's the thing. I kind of get stuck at the meaning part. I was trying to, early on, I was trying to go, what does this actually mean? What does this really mean? And the abstract way of learning it was very difficult for me. So I tried to kind of go with I need to find some applied example. I need to find some equivalent in the real world where I can map this to, because that must be meaning in some context. But then even the simplest thing, truly the simplest thing of suppose we start with basic arithmetic, and I teach, a child 5 plus 5, they'll go, okay, that's 10. And I say, great, now just imagine that's coins, right? 5 coins and 5 coins, you have 10 coins. Now take 5 coins and subtract the 5 coins. Okay, great, I have 0 coins. Okay, now subtract a negative number, and then everything just breaks. And I felt that thing constantly happening of trying to go, let me find an applied case, but then it didn't take me too long to go, it doesn't fit. There's always some kind of way where I can turn the applied case into something that doesn't really align. At least it felt like that oftentimes. And I suppose that it's kind of going back to the friction of going, it felt like all my life I've learned things, finding some kind of physical manifestation of whatever this is. Mm-hmm. So to do math properly, it's so fascinating to me how much I've kind of been sitting with that thing of going, I need to find them. I need to find the equivalency, because otherwise I can't get this. There was another passage which was very interesting to me. This is obviously stepping into much more complex math, but it's a quote by, I'll actually kind of be curious even on your take on this person specifically, John von Neumann. Obviously, very impactful person in a lot of ways, very inspirational. He has a quote where he's in Los Alamos and he's speaking with a physicist. The physicist is stuck with something, and von Neumann gives him some kind of feedback. I think specifically I mentioned here, it's the method of characteristics, which is a technique to solve partial differential equations. And then the physicist is like, I can't really, why would you do this, whatever. Mm-hmm. And von Neumann replies, obviously a little bit in jest, right? It's a little bit, you don't get it, it's good. He says, young man, in mathematics, you don't understand things, you just get used to them. Oh my God, it's, yeah, of course. I feel like everything I'm going to throw at you is going to be, revisited 50 times. Can you kind of touch on that? What does that even mean? Is that the simple example to me would be, I look at the Pythagorean and I go, I've just seen it so many times. I know instinctively that this is true. This is the only way it can be. But I can't, or maybe it's possible, yeah. Actually, give me your take on this entire thing.
So I told somebody this last week, actually. But we were talking about a much more complex, we were talking about a super complex object. And I wrote down the definition, and I'm just like, so there it is. It's like a mass of axioms. And I can give you some examples. But I said I saw this definition for the first time 30 years ago. And I realise now when I'm writing it down that I don't understand it any more than I did then. But I'm not remotely scared of it because I've seen it so many times that it's just, I just know not to be scared of it anymore because I can't understand. It doesn't fit into my head. There's no physical representation. This is some crazy infinite dimensional object that has no meaning in reality in our universe at all. But it's just the same, just like a right triangle, right? It's just defined by some axioms. There it is. And even though you can never instantiate it in reality, it's still, it's definitely a thing in the Platonic universe, and you can manipulate it. Even though, and I don't feel like I understand it. I can't see it, I can't touch it, but I can manipulate it because I've done manipulations with it so many times before. I know what you can and can't do with it. It's like having a super complex tool with like lots of buttons and switches. You've got no idea how it works, but you want to do something with this. You attach the tool to something and you press the buttons and it does the job. It's like how it works, you don't know. But that's exactly, it's no different to a car, right? You don't understand how a car works. Well, I don't understand how a car works. But you can still drive the car.
I guess,
so
but it feels like with the
draw
car, though,
a line.
you could, if you wanted to, you can understand the car and what makes it move and, how does the gearbox work. Like, it feels like at least with the car, you could decide to understand why it moves the way that it moves.
You can't though, because there's always you understand it up to some point. Like because you don't understand, at some point there's some you can quote understand the engine, but you don't understand the engine because
you kind of get down to the same thing of nature decided that this is the only way and then you have to kind of understand nature again, which is to get back to that.
Yeah, exactly. There's some kind of chemical crazy.
Okay, fair point. Yeah, you got me back.
Okay. You draw the line somewhere, and then you say, "This is enough for me."
Yeah, that's so good. This is the abstraction where I stop and I just accept.
Yeah, and beyond that point, it's just the same with computer science. You kind of think you understand. You learn a programming language. It's like, okay, now I understand coding. But then actually that programming language is sort of translated down into like a string of zeros and ones, which are then represented by like little electronic pulses, which are stored on some chip. But at some point it stops being computer science and it starts becoming physics. And, at some point you draw the line and say, I understand how stuff's working up until this point. And then beyond that, I'm just axiomatic, right? You put it in a box.
Yeah.
You say, now I'm just going to believe the following basic principles. So that's how our understanding of everything works.
Yeah. Right? Yeah. Okay. That's a good equivalent. I think it's a nice way to kind of draw it into the real world and how this essentially happens all the time, even unconsciously. Even if I think I'm an expert of cars, even if I think I know the entire hardware stack, you're right, from assembly to machine code to logic gates to whatever, I still essentially implicitly accept some kind of abstraction from which I build everything else. I don't actually. Why did you do that, Kevin? Why did you? No, but it makes total sense. It makes total sense. Okay, then I want to zoom in a little bit on mathematicians specifically and kind of what it is that makes mathematicians potentially unique from other people, and have a few ways to approach this. I'll start with like the mysterious one, like the mysterious enigmatic one, which is, you're going to notice a pattern here. I'm going to take quotes all over the place.
Okay.
All right.
I'll stop finishing them.
No, please do.
Right.
I enjoy that game. I was about to say, even if it would be fun at the end of this to kind of brush up and go, how many of these have you heard? Which of the ones have you been heard repeated more times than the others? All right. Withstanding, this one comes from a non-mathematician, which is why I think it's a little bit enigmatic. It's always interesting to hear about people outside of a field speak of people inside of the field. Yet, it's probably one of the most household names ever, one of the most impactful scientists ever, and it's, of course, Charles Darwin. And he says, during the 3 years which I spent at Cambridge, I attempted mathematics, but got on very slowly. The work was repugnant to me. Chiefly from my not being able to see any meaning in the early steps in algebra. Mm-hmm. This impatience was very foolish, and in after years I have deeply regretted that I did not proceed far enough at least to understand something of the great leading principles of mathematics, for people thus endowed seem to have an extra sense. But I do not believe that I should ever have succeeded beyond a very low grade. In my last year, I worked with some earnestness for my final degree of bachelor's and brushed up a little algebra and Euclid, which later gave me much pleasure as it did at school. So I guess two things. The first thing is also, it's pretty crazy to hear such a distinguished scientist and such an impactful person go, I struggled with math. It came about very slowly. The early steps were very meaningless to me. But obviously the second thing here, which is, I mean, for him to say mathematicians has a sixth sense, I can't think of a greater compliment to give to a person than to go, whatever you have seems like something almost like extraterrestrial. Like it's beyond. Can you touch on whatever the hell you think Darwin was talking about? What do you think that is?
I'm not sure that he needed any abstract algebra to do what he did, right? Because he was very much interested in, an aspect of the physical world, right? He was interested in a practical question, the origin of species. And mathematics models the world, right? The basic questions about genetics can be turned into abstract mathematical questions, which you can then solve without having to know anything about algebra, right? You don't need to know. You don't need to know even the beginnings of modern algebra. Just to understand, just to start making predictions about, just goofy things like, how many people are going to be left-handed and how is left-handedness going to work? And, you can start doing those experiments and just figure out the math yourself, right? But then there's people that just want to think about the math as, just by itself, not worry about the application. This is the thing. The moment you stop worrying about the applications, then you've just got then you're just running into this Platonic universe in any direction you like, and who even get you? Then you're doing blue sky research, and people. That's the moment when you choose, right? You want to do it for its own sake, or you want to do it. You want to develop the things which are important. Yeah. And historically, we have seen people like Hardy famously said. He was doing number theory, which was this supremely useless thing. And then sort of decades later, it was being used to kind of create unbreakable codes that then became the sort of the basis for encryption of things like credit cards. So you can argue for blue sky research that way. But the vast majority of blue sky research is not going to be used, I suspect. Yeah. And so, I mean, it is a sixth sense, but it might not be a useful one. Is the understanding of the abstract. It only gets you a certain. In reality, it only gets you like each sense. It's sort of useful in places, but not useful. If the lights are off, then it doesn't matter if you can see, right? It's sort of. That's good. So it's it's a tool that sometimes you can use if you're in a position where you need abstraction. Then mathematics is perfect because it. Mathematics is the language that we use to explain physics, and physics is the what we're using to explain reality. But there's only a certain there's certain uses.
Yeah, that's kind of interesting. Okay, so I guess there are two conclusions I get from your response here. The first one is you don't necessarily need all of math to be able to solve whatever practical problem you're working with. Darwin doesn't need abstract algebra in this case to be able to do all of the stuff that he actually ends up doing. So, which I think is a good case. It's not like an intimidation part, or not even it's not like a prerequisite thing that if you want to make any type of impact to the world, any type of advance, you have to know all of the whatever additional fields of math. And the second thing that you mentioned, I think is also interesting because if we play along with this sixth sense idea, you're saying there is a sixth sense, potentially, which is you can understand things abstractly, that you can essentially cut through this physical world that we exist in, and you can think much more freely about structures that don't have any physical instantiation. But then the tie-in to that is not necessarily to say this is a superpower and it's going to change your life forever, but it's more of it has applicability somewhere, but it also has, not applicability everywhere. It's not necessarily the thing that's going to, drastically improve your life and now everything is sunshine and rainbows. Is that a correct take? Roughly summary?
Right. Negative numbers are a great example of this. Right? They didn't exist for millennia. Pythagoras, the ancient Greeks, they didn't know about negative numbers. But then when you kind of realize it's sort of this idea that if I give you some money, then you've got more money, but I've got less money, and we can actually model that by saying I have a negative amount of money. Yeah. It is sort of and then you give me some money and then we can kind of work out what's just happened. by doing arithmetic with negative numbers, you can see, you can sort of reinterpret everything by, you can rephrase everything with positive numbers, but if you allow negative numbers, we just have that extra degree of freedom. Even though you can't take that, you can't make like negative £5. A negative £5 note is a useless thing because I just like throw it in the trash and I've made £5, right? It's sort of, so that there's some points where the abstraction doesn't work, but on the other hand, negative numbers are super useful. So we take them, we don't say they, quotes, they don't exist in the same way that positive numbers exist, but you put them together and you've got a really useful tool. You know, you're better at doing arithmetic because everything got a lot simpler. When they were trying to solve cubic equations when they didn't know about negative numbers, and there's lots and lots of cases, because a general cubic equation, it's like x cubed, and then there's some number times x squared and some number times x. And now these numbers, they can be positive or negative. And in the 16th century, they were sticking them on different sides of the equation, depending on whether they, and then doing lots of different cases. And then when negative numbers came along, I was like, wait, you put them all on one side of the equation, and it's just like, and all the arguments are the same. This is a great, so abstractions get you further, even if they don't actually exist, you know. Negative numbers don't exist, but you know, if a car's going backwards, then it's got a speed, but it's got a velocity, and now suddenly they're different things because the speed is just a number, but a velocity has a direction, and these subtleties that you understand, suddenly you're better at doing physics because you're understanding. Even though negative numbers don't exist, they're doing a much better job of modeling reality.
That leap into abstraction, it almost feels like you have to, I don't even know how to necessarily go about this. It feels like leap is the best word I can come up with. It feels like, or embrace. It's like either I have to leap into the abstraction or I have to embrace it purely, and I have to let go of the physical. And you're right, maybe with negative numbers, whatever, we can find some kind of physical equivalent and go, wow, it actually models really nicely. But the idea of treating it fundamentally as something abstract, or obviously something that's hilarious, like imaginary numbers, does not really do anybody any favors with that name. But
you couldn't do quantum mechanics without them. Right?
Exactly. So it still has a physical instantiation, which is hilarious considering the name of it. But the idea of saying I just have to embrace the abstract, I have to embrace, let's say, we call it the Platonic Realm, this thing that exists completely independently, like that feels like it almost feels like a choice that you have to make as a human. You almost have to consciously make it. And if you don't make that choice, you will constantly experience friction with math because basically my example, I just keep running into, crap, what's the physical, versus just saying, you know what, it's all good. Let's just play with the numbers and the symbols and appreciate them for what they are. I'm just trying to think about, I guess I have a couple of questions. One is I would be curious about your own journey into math with that one of, was it always an intuitive thing? Did you always kind of look at math and go, I never had that type of friction. It just came to me like the most natural thing. Exploring the Platonic Realm before I even knew it was a thing, which is the most natural thing. Was there like a transitory phase? Let's start with that maybe. I think that would be an interesting point to kind of jump off of, and we can tee up after.
So I embraced that abstractness from a very early. I was always gifted at maths, and I wasn't that good at most other things. And when I was a kid, I just thought I was good at math, and I'd just been lucky. I'd been born with a gift, and the fact that everything in math class just seemed trivial to me was because I was lucky. Interesting. And I didn't have to do any work for my homework. But then I understood much later on that this was nonsense, and what was actually happening was I was good at math because I was spending all my time doing math. It was actually because I was working extremely hard, not at the math I was being given in class, but other math that I was sort of finding, not online, of course, because there was no online in those days. But my father had some math. My father worked at a teacher training college. He taught people to be maths teachers. So there was maths books at home that I would plough through. Wow. And then there were maths books at my local library, Hardy and Wright's book on the theory of numbers. So I was sort of reading, 1800s number theory when I was still a high school kid. And I think that the moment you're into that world, they're just giving you the abstract. They're not talking about any. They're saying, here are the abstractions. Here's how it works. Here's numbers mod p. Here's complex numbers, and they're not. Nowhere does the question come up as to why. These are not philosophy textbooks. These are just saying, here's how math works. So it was into my head from a very early age. That, when I was young and brainwashable, it's like, this is a topic. Here's how it works. No, don't ask why. Just get on with it. So I'd seen the abstractions from very early on, and I just got it. And then when I went to university, I saw a bunch more abstractions. I was just like, okay. So, I understood the nature of the subject, I think, quite early on.
That's amazing.
Because it was a world I could make sense of. My confused autistic brain. It was just like, reality is full of such noise, and here is something nice and safe. So I spent a lot of time in that sort of safe world, and sort of never left it somehow.
Wow.
I just, went to university, became a student, and I'm still at university now.
That's incredible.
Sort of,
Yeah, that's absolutely incredible. Okay. I have like 3 questions simultaneously.
You want to write them down?
No, I'll try to.
All right, good luck. I would forget.
Yeah, I love that. Good luck. Maybe I'll use one of your notes.
Yeah, go ahead.
Let me do. Okay, the first one I'll start because this one is generally a bit funny / strange, and it's So there's something interesting about saying if I look at you, Kevin, and I go, hey, Kevin, I can't do math. Not a math person, me and numbers, we don't get along. That's like kind of funny. At least it's acceptable, right? We can kind of laugh about it, haha, okay-ish. But it's not crazy to hear people say, I was not a math person. Like, I'm not a math person. I just don't have it. Kind of back to your genetic component, like either you have the math gene or you don't have the math gene. But obviously, if I go, hey, Kevin, I can't read. It's a little crazy, right? Me and words, we just can't. I don't do that. That's insane to most people. Very disturbing to go. So clearly, one is acceptable, the other isn't, and it seems
in this culture, in our culture.
That's exactly because that's the tee up. I was in Japan and Korea a couple of months ago, and then it seems like the Eastern perception of it is that mathematical ability is way more just a function of effort. So if you're really good at math, it's because you put in a lot of effort. And then you could talk about upsides, downsides, etc. But I guess I want to explore both of those questions. The first is, do you think there is anything to that math person or not? To me, it obviously seems an easy coping mechanism to go, if I'm bad at math and I don't get it, one day when I die, they'll check my brain. I didn't have the math gene. That explains everything. Whew, great. I can just kind of go on with my life and not worry. But maybe there is something there, right? Some people just, because the idea of abstraction could seem like it's, you just one day go, there we go, I get it. And now math becomes, wow, it's an explorative whatever. And some people, if they never get it, they never see the beauty, it just becomes there's nothing in this for me. And then obviously the Eastern-Western-ish dichotomy of, they perceive it so differently on the spectrum of, how does one obtain mathematical ability? But if we start with the first one of, is there anything to that mathematical, math person or not? Or is that something that we shouldn't take seriously?
I don't know. I mean, obviously, I've met many people who are like, I couldn't do math. And, I mean, I couldn't do history, right? When I was 15 years old, I had absolutely no interest in history.
Missing the history gene, that's
I was missing the history gene. And I gave up history very early at school, and years later I regretted that.
Interesting.
I became a sort of a more broad person, and I regretted it. And now I pay much more of an interest in history. And I think that maybe if it goes the other way, you like history but you don't like math, and then years later you might think, I could get into math more now, but like it's just a bunch of abstractions. And like how do you get into math when you're in your 30s? Yep. It's kind of clear how you get into history. You can start reading about the Second World War and, begin to understand, or the atrocities that your country committed in the Middle Ages or whatever. And, it can open your eyes, but it's much more difficult, I think, to, quote, get into math later on. Because it's this very, in some sense, a very dry subject, or if you're not careful, a very dry subject that, you can read about parts of it that have nothing to do with reality at all.
Yeah.
So it's sort of, where's the hook, as it were?
Yeah.
So yeah, maybe it might just be about maturity, or it might just be about, you probably, if you want to learn some math, you should probably be if you're interested, right?
Yeah.
If you're open to the idea of math, then maybe it's going to be a lot easier to get on top of. And I can quite believe that people are and are not open to that idea at different points in their life. So the people that weren't open to that idea when they were kids, they just missed the chance. Yeah. Maybe.
Yeah.
So with his, I was lucky in that I can read. I can read about the history of my country even now. Whereas I learned math at a young age when I had the time and space in my world for that. But yeah, I don't know. I mean, who knows how it works? That's my guess as to how it works.
Yeah, absolutely. I think the motivation has to be, at least it's fundamental. It's absolutely fundamental. It seems very difficult to learn any subject if there's no motivation. If this is boring to me, it's completely pointless. Like, there's holy smokes. Maybe I can memorize some of the things and I'm really forced to do it. Yeah, but the actual intrinsic learning of going, I get why, it's at least anecdotally, never happened. Never. I completely instantly forget it if I'm not motivated to do it.
Right.
And I can see with math, and I guess there's an interesting also distinction between you're right with history, you can kind of start anywhere. You go Genghis Khan, or you do whatever type, you go, and you can kind of dive into it and enjoy everything. With math, I can't really go directly into calculus if I don't have any of the prerequisites. If I don't know any trig, or if I don't know any basic algebra, I can't really do it. And so I have to kind of go. So it feels like, if I want to do the Second World, I can't do the Second World War because I have to go to World War. I can't do that because I have to go.
You can just dive in.
Exactly.
Right? You can start the Second World War.
So I think that thing is super interesting, that the expansiveness of math and how ruthless it is in like prerequisites, I think is pretty interesting. Now you can argue that a lot of the natural sciences have the same idea. It's very difficult to go into quantum mechanics if you don't have any of the kind of same fundamental prerequisites going into that. Oh, interesting.
Math is parts of math are these gigantic. Yeah, you can't suddenly decide that you want to be interested in algebraic geometry, right? Because algebraic geometry is this gigantic sort of tower, this huge tower, with people at the top just building higher and higher and higher. Right, that's what it looks like.
Yeah.
But at the bottom, there are these sort of thousands of foundational pages that it's sort of very difficult to take them on trust. There's so much stuff there that it is. You don't just want to say, well, like every you have to sort of have a feeling for what's going on. It's difficult to start with research algebraic geometry if you don't have you know at least something about the machine that's powering it.
Yeah.
Whereas that is not all of math is like that. You can start thinking about Erdős problems. Erdős was a prolific mathematician that wrote lots and lots of questions that typically each question you can typically explain to a school child. So math is weird, right? There's every even number 4 or more is the sum of two prime numbers. We sort of suspect this is true, but nobody can prove it. This question's been open for hundreds of years. Like 4 is 2 add 2, and 6 is 3 add 3, and 8 is 3 add 5, and 10 is 3 add 7, and 12 is 5 add 7. Like, what the heck? So that's an open problem. So math is it is possible to get right to the boundary of math in no time at all. Yeah. But you're unlikely to be able to prove that statement, right? We don't just want to state it; we want to prove it. And probably to prove it, you need machinery. And then machinery we have to then build. So that's where all the work comes in. First, you've got to learn about the machinery. And now this is pages and pages and pages of modern techniques. Of course, we don't even know which machinery is relevant. There's a question we can't do. So we don't even know which machinery is relevant. So maybe you want to start by learning all the machinery in math.
And only then can you dissect what the hell is actually relevant here.
And now all of a sudden, the job is becoming difficult.
And maybe that actually lends itself nicely to a next point that I have. Right before we started taping, I hope it's okay I say this, you were reading a paper and you said, so do I want to deeply understand this, or do I want to use it? I hope it's okay if I don't
All my secrets.
Yeah, yeah, spilling all of Kevin's secrets. There you go.
Yeah.
There you go. One thing that to me was very interesting about math, and I think one of the reasons why I think it was so interesting is because I didn't expect it to invoke so many different fields. So when I first started doing math and I kind of tread through the, literally from basic arithmetic to algebra to trig to geometry, analytic geometry to like early calculus and linear algebra and whatever, I kind of trace through all of this stuff and I go, but how is this true? And then I go, okay, we need to figure out how to prove this stuff. So now suddenly we get into logic. But then I go, okay, but we need to start with a premise. Where does the premise come from? Okay, so these are axioms. And it doesn't take long before I'm in the philosophy department and I'm kind of going, okay, it feels like I need to figure out what the hell knowledge even is to begin with. I need to study epistemology.
But you can draw the line. Just say, these are the axioms that
Okay, and I can buy
you have
that.
to know
You're
when
right.
to stop.
It's true. And maybe that's also a kind of the machinery part of like which part of the machinery is relevant and which isn't. But suppose I then do that, we go there, and then I go, okay, maybe this is back to a previous point. I'm going, okay, now I'm trying to figure out what vectors are in vector spaces, and it's a bit abstract, so let me try to find some kind of physical equivalent. And so, that's a mistake?
Well, I don't know. Maybe examples are useful. Maybe if you're weak,
Wow.
you need examples.
I didn't expect this to get called a weak. Now here we are.
No, I'm very weak.
No, it's okay.
Sometimes
You're gonna have
one of
to.
my best pieces of work was working out an example.
Okay.
There was some crazy p-adic object that I wanted to understand, and I thought, okay, damn it, I'm going to work out an example.
Oh wow. Was it difficult to find an example?
I mean, yeah, it was a lot of yes.
Yes,
It was a lot of work. There was this mathematical object, and I knew that it was defined by an equation, and I figured that I wanted to work out what this equation, like, there was a mathematical object, for each prime number there was an object, and I wanted to understand these objects. They were this new thing, eigencurves, they were this new thing, everybody loved them, they were doing this great job, they were explaining phenomena that we didn't really understand probably before. And I was just like, yeah, well, this is all well and good, but like, what's an example of one? So I took the smallest prime number 2, and I tried to write down the equation that, defining this curve. Yeah, and it took a few months to work out how to do that.
Wow.
But once I had it, like I had a computer program that sort of worked out the first, 100 or so terms of this equation. And then I looked at this equation, was like, whoa, there's a kind of crazy thing that like no one had ever spotted.
Wow.
I was like, this equation has some crazy property. And then suddenly this became a conjecture. Maybe all these eigencurves had this same property. And this was like open for 20 years, so maybe 15 years. And it was ultimately solved. Yeah. So working out an example is sometimes a really good idea. But yeah, I always joke that, working out an example means you're weak because
That's hilarious.
because you don't.
I can kind of see the idea. You kind of give up to the abstraction and say, you know what, I can't see the abstraction, so let me try to find like an actual example that I can better understand. That's a fun.
You're not going to prove any new theorems that way. But with the example I worked out, we came up with a new conjecture.
Yeah.
Which sort of drove the field in a certain direction.
That's amazing.
And it did give insights.
It's amazing.
So sometimes examples. Yeah, okay. So maybe vectors. Yeah, we live in a vector space. It's like that direction. It's 3 dimensions.
Yeah.
Okay. If you're interested in 3, then okay. Then
great. It's easy. We can kind of keep it there. That's it. Once
like
we go.
n is fine as far as I'm concerned. If you want to get the hang of it, then you can think about 3, or you can even think about 2. It's probably a 2-dimensional vector space. Yeah.
Does that? I mean, maybe this is the example part of saying what's the simplest possible example, like a baby example, and from there it's much easier to generalize across and go. If I understand 2 or 3 dimensions, then understanding 4 and 5.
No, 0 dimensions. That's the simplest example. So it gives you no insight whatsoever, right?
That doesn't help you at all, Kevin. You just go to
You've got to get the sweet spot.
Oh my God.
I wonder whether if sort of the universe had been 2-dimensional or 1-dimensional, then our understanding of geometry would be far more. If the human brain's understanding of 3 dimensions were far more limited because it didn't quote exist, then probably our knowledge of geometry would just be way. Yeah, we would be much better at arithmetic.
That's so interesting.
It's 3 dimensions is a really good number because it's not the simple. As I say, the simplest case is 0 dimensions, and then you've got 1 dimensions where humans all live in this straight line and you can't get past somebody. You're just like literally right? You can't get past someone.
Yeah,
so we're all in an order.
Annoying place to live.
You just talk to the people next to you.
Yeah,
that's kind of why you're
stuck with these two idiots.
Yeah. So that's a catastrophe. And then 2 dimensions. People have written novels about 2 dimensions. There's this novel Flatland.
Yeah, that's right. Yeah,
2-dimensional creatures.
Circle/sphere.
There's like people trying to understand objects that we think of as trivial, like cubes and spheres. This is like blowing their minds.
Yeah, of course.
But then, if it's just the same, there's 4-dimensional objects that we wrestle with.
Yep.
But somehow 3 dimensions is good enough to have knots, right? Yeah. You tangle a piece of string and you tie the ends together, and now something interesting is happening. You can ask yourself, like, can you untangle it without snapping the string? And this turns out to be a very complex and rich question. And I wonder whether, things like knot theory, if we were 2-dimensional, 2 dimensions, you sort of can't make a knot. You're sort of much more limited. There's this.
Yeah, I'd imagine, because you would have to use
Jordan curve theorem.
Yeah.
So if you've got a bit of string and you join the ends together, there's like an inside and an outside, and you can sort of straighten it out. If it can't cross itself, in 3 dimensions it can cross itself, and all of a sudden you've got this rich theory. And knot theory would be this crazy abstraction if we were 2-dimensionals.
Yeah, because
in 3 dimensions, knot theory is a real thing, because like knots are really important.
You can see it, literally see
you
it.
tie the
of course
ship.
It must be. That's an interesting thought example, trying to kind of imagine the world, what it would mean to live without a 3rd dimension. We'd be limited to 2 and how that changes.
But what if we lived in 10 dimensions? Then suddenly, what great insights do we have? It turns out that like 3 and 4 dimensions are the rich ones.
Yeah.
Like in a real sense, the moment you get to 5 dimensions or more, things get quite boring.
Oh wow.
There's things like dodecahedrons, right? They're these crazy shapes. They're dodecahedrons, and in 4 dimensions there are kind of like crazy 4-dimensional shapes. But then the moment you get to 5 dimensions, all the Platonic solids are very, very dull. There's just like there's the cube one, and then there's the sort of the tetrahedron one, and that's basically it.
Maybe actually then on the topic of this, let me ask you, because I actually think it ties into something nicely about the conversation in terms of abstraction. So now we kind of have a good excuse. We have abstraction and geometry here. That's a good excuse. So it seems like the sixth sense of mathematicians is they can follow abstractions very cleanly that normal people can't, because they're just exposed. They're just used to the freedom of going, I don't have any limitations of the physical world, so now I can just think freely.
You've got limitations of the axioms.
That's
don't
right.
Go too nuts, right?
Yeah, that's right. Absolutely. So you're right. You're obviously constrained by axioms, but outside of that, there are no constraints outside of it. It just has to be consistent, and then we can kind of create things that don't have to exist here. Yeah. And then when we kind of look at geometry, there is something very interesting to me about, not necessarily, there's obviously the fact that Euclidean geometry, the flat space geometry that we're talking about, or we've spoken about, is kind of the only geometry for 2,000 years. And then Gauss in, early 1800-ish, Gauss does something very interesting, which is he has a passage, and I have it here somewhere, and I'll read it to you, the first passage, and I'll read the second one. So he says, the assumption that the sum of the 3 angles, so he's obviously talking about a triangle here, the assumption that the sum of the 3 angles is less than 180 leads to a curious geometry, quite different from ours, but thoroughly consistent, which I have developed to my entire satisfaction. And so first, just to tee out for people who don't know this, I literally brought, because I juggle, which is hilarious.
This is some Escher. Oh no, you brought a sphere.
One of these, yeah, I brought a sphere. Which is, the basic idea here is obviously triangles can sum to 180 degrees in flat land. For this juggling ball specifically, it's made literally of just patches of triangles, but if we consider each angle separately, it's 90 degrees, 90 degrees, and 90 degrees. So it doesn't sum to 180, essentially the point.
So I was confused. When I was a kid, I was always confused by this example, because I was like, well, that's not a triangle because the lines aren't straight. And it took me a while to realize that those lines are straight. If you're like constrained
within
to the sphere, then a straight line is the way you're going to walk. So the way you get from there to there, right? How do you get from there to there? Yeah. That's the way you walk. Yeah,
that's awesome.
So even though it's not, quote, straight in 3 dimensions, it's a straight line in that geometry. This was the thing I never understood. That's why this is a triangle, because the sides are straight. But all the angles are 90 degrees. So sums to 270.
It's an amazing example. I think this kind of goes, I'm not, okay, I don't want to dive into this one, but it's the same thing where I go,
there's like the rest of it, that's a triangle as well, right?
Yep.
You remove that triangle, then all the rest of it, that's a triangle, because it's bounded by those 3 straight lines. And now the sum of the angles, it's like, now it's massive. It's because it's like 90 times 9.
Yep.
Yeah, the bigger the triangle, the more the angle sum, right? You can work out the area depending on, if you draw a super, super tiny one, then it's just a little bit bigger than 180.
Yeah, that's so interesting. Yeah, that the size of the actual triangle itself has an impact on
the sum of the angles.
Some of the angles, which is obviously completely crazy to think about when you think about normal Euclidean geometry. But okay, I won't go into this question, although maybe I'll do that later. The point of this thing is, if we kind of go with the assumption that mathematics is very much about embracing abstraction, you have to go there. I would imagine that after 2,000 years, someone finds, it's not just someone, right? Probably at that point, the greatest mathematician, the prince of mathematics, finds a type of geometry that's completely different. I would imagine that the mathematical community would all bond together, kumbaya, and go, whoa, amazing. But the next statement from Gauss is, he says, to work up my very extensive researches for publication, and perhaps they will never appear in my lifetime, for I fear the howl of the Boeotians. I don't know how this is pronounced. Boeotians. If I speak my opinion out loud. And Gauss literally goes on to never publish his works on non-Euclidean geometry in his lifetime. It's only post-mortem that it's actually published. There's a little bit of I can't reconcile those two things with going, no limitations outside of the axioms, go crazy, and then but don't go too crazy. Like, it feels, I don't know what that is. What's your take?
That is funny. Maybe that's a historical relic, maybe. I don't know. Maybe he wasn't allowed to do proper blue sky. But all the number theory stuff, that didn't really have any applications at the time, and he was allowed to do that. I don't know. Maybe did numbers quotes exist? What existed back then? Were numbers allowed? The counting numbers, they existed and they were things. So figuring out things about counting numbers is okay.
Yeah.
Whereas so hyperbolic geometry, this thing he's talking about, maybe it didn't quotes exist. I don't know. And so he wasn't allowed to. Yeah, he was just unlucky.
That's so interesting.
Maybe numbers exist. I don't think you could have asked Gauss what a number was. He would have just said a number was like a fundamental, a fundamental thing, and you don't worry about what they are.
Yeah.
If we believe that they're there because you can count stuff, then numbers are worthy of studying. Whereas hyperbolic geometry doesn't manifest itself in the real. Numbers manifest themselves in the real world. Like positive integers, we can count things. Real numbers, their lengths, so they're meaningful things. Whereas, hyperbolic geometry, it's just a cool abstraction. Yeah, there's nothing stopping us. He was just rotten luck. Him.
Oh wow.
He was too early.
Interesting.
Maybe there were weird rules about what you were allowed to study back in those days. I don't know. Yeah. Now it's free reign.
Now it's there because I guess the next question that I wanted to pose is, I know like Cantor with set theory has some opposition, and so I guess my general thing was, is there some element of like the mathematical community being like dogmatic, that there's a view of this is the type of math that we want to pursue, everything that doesn't fall into this semi-defined box of good mathematics, we will, in this case, it almost seems like condemn. We will literally oppose it and say that's not what it should be. So in that sense, is there, a narrow-mindedness in what constitutes like good mathematical research, or is it like pure, free, all kind of goes?
Yeah, okay. So I should firstly say, Gauss and the hyperbolic geometry, I'm not a historian. I've got no idea why things happen the way they. So I probably shouldn't speculate. But talking about what's happening now, it's certainly true that there's fashions in mathematics. There are abstractions. I think it's difficult to just come up with a new abstraction with no applications and then develop it. You are going to have a hard time. What the community are really looking for is an abstraction which makes mathematicians' lives easier. For example, an abstraction that solves a problem. The moment you have a new abstraction, you might be able to ask 100 questions about it. I've invented this crazy new theory of foo bars, and now I can ask 100 questions about foo bars, and you can then go on and answer some, and then attempt to publish your theory. But I think nowadays the acid test of a theory is if you can use your theory of foo-bars to answer a question which mathematicians that didn't mention the word foo-bar,
Awesome. Yeah.
but it was a mathematical question that people had tried to study, couldn't figure out, and using your theory of foo-bars, you can resolve that question. So suddenly that's an application of foo-bar theory, and now all of a sudden foo-bars are a really important thing. Right? That happened with Peter Schultz, who came up with this idea of perfectoid spaces. It was a very good name because they sounded very exotic, but they weren't just developed for their own, for their own sake. He did develop a lot of the abstraction of perfectoid spaces, but somehow within 10 years of their discovery, they've been used to answer questions in geometry and number theory and algebra, which didn't mention the word perfectoid space, but you could use perfectoid spaces to solve them. And then, people realize the importance of the abstraction, and then he gets the Fields Medal. So and then on the other hand, I get crank emails from people who've developed a theory, and these theories might be completely valid. Yeah. It's like, okay, you've made a new thing, and you prove results about your thing.
But no applicability to any other.
Who cares about your thing? Does it actually help with the big questions? Oh wow! Right, there are big questions in mathematics, and maybe Gauss was too early. Maybe hyperbolic geometry. I mean, hyperbolic geometry did answer a question that was open for hyperbolic. Hyperbolic geometry answered this question of Euclid as to whether the parallel postulate was. But then maybe, you see, I should be careful what I'm saying. Does spherical. Maybe spherical geometry gives a partial insight into parallel postulate, but hyperbolic geometry completely nails it. Because it's just like, here are two parallel lines that don't meet, like, end of story. Yeah, I see. In spherical geometry, it's still true that parallel two lines, if you extend them, will meet. Right. So, whereas in hyperbolic geometry, you can find parallel lines. You can extend them both to infinity, and they don't meet at all. So, it's answering a question. I don't know what he knew. I don't. Maybe nobody. I don't know.
Yeah, it's so interesting. I know there's some general historical context about Gauss.
You know more than me. Yeah.
I definitely don't, but maybe I know more of the historical. There we go. History coming to the rescue. There you go. He had the few but ripe philosophy. So if it isn't perfect in accordance to his standard, he generally doesn't publish. So maybe there's something there, and he recognizes his role as being leading in the community. So maybe he's just fundamentally very, very careful about whatever it is that he publishes. So maybe there's something there. But there's something interesting, which also ties back to, you mentioned this fifth postulate, the parallel lines postulate, which obviously comes from Euclid, and that's his fifth, basically, axiom postulate, etc. And there's actually a friend of Gauss called Wolfgang, I don't know how to pronounce the last name, Bolyai, who speaks on this thing exactly. I have another quote. I have all of the quotes, so it seems. And he says, and actually before I do that, the context to this thing is, obviously it's nice to tease up with the fifth postulate, but that's not really actually the thing I'm curious about. When you previously said you were drawing out the example and you found you with the prime number of 2 and you were kind of doing this thing and it took you months to do and da-da-da. There's something very interesting to me about the unknowingness or the uncertainty of doing mathematical research, and you don't know if this is going to yield anything, is it going to be fruitful, are you going to get stuck, whatever. And I suppose that thing psychologically to me is very interesting to explore. And in this case, the quote specifically from Wolfgang is literally relates to this parallel lines postulate, and he says he's talking to his son Johann, and we can touch on him as well because he is basically credited with developing non-Euclidean geometry after. But father says to son, "You must not attempt this approach to parallels. I know this way to its very end." This is such a crazy quote. "I have traversed this bottomless night, which extinguished a light and joy of my life. I entreat you, leave the science of parallels alone." I can hardly stop smiling.
He just got stuck.
Wild, yeah.
That happens.
That's such a wild quote to have so much, essentially passion. It feels like passion is just radiating. It's not just passion, but like passion and bitterness, like combined, radiating from the quote of going, I dedicated so much to this thing, it didn't yield anything at the end of the day. Please do not. That thing, can you kind of speak on like that thing for mathematicians of going, you don't know if you dedicate years to something that never gives you anything at the end, and how do you deal with that?
Oh, yeah. I mean, research is gambling, right? You're always gambling. It's like, okay, I'm gonna devote my time to trying to solve this problem, and then you try and solve it. And if you've chosen the wrong problem and you can't solve it, I mean, then typically what happens is after a while you give up and you publish what you have. There is an art to finding the right. Progress is made by finding the right questions. Right, this is part of the art of mathematics. You understand what's been done, and then you try and get a sense of what's doable, and then you go do it. And if you get it wrong, then, I mean, if you get it wrong, then all that happens is you don't publish.
Yeah, it's
right?
sour grapes. It is what it is.
It's and there's plenty of there's these piles of paper here, right? Some of them just contain ideas that never went anywhere, and as a result, nobody gets to see them. Or I bump into people. You bump into people at a conference and they say, I'm working on X. I say, I once thought about X. Got totally stuck. You don't say, don't work on X. Like, here's everything I know. Yeah. Here's what I figured out. Maybe that helps. And then this is where I got stuck. So, it's a collaborative game, mathematics. And, I mean, at least that's the way I play it. Yeah, people play it in different ways, but that's the way I always played it. It's when I had young kids, especially, my head was full of ideas. And I had like 3 children and doing a lot of, childcare and not much sleeping. And you just give your ideas away at that point. Here's some half-baked stuff. You give it to a PhD student and see what they can make of it. Because you just know that if you keep it for yourself, that's a selfish act, but B, it's also might be confining it to the dustbin of history.
Yeah. So it has the ability to generate ideas over the years. Has that do you feel that ability has strengthened, deteriorated? Has that seen any change?
Oh, what a weird question.
Yeah, you're welcome.
The thing that I really feel has clearly deteriorated is my ability to keep up with the literature. Because when I was a PhD student and had all the time in the world to think about mathematics, I wanted to completely absorb, the totality of known knowledge in my area. You can't read all the papers because they go back forever, but you can attempt to read all the important papers, and some of those papers you can attempt to really understand from the basics, and others you can attempt to at least understand what the point is, understand the statements. And then you're at the forefront, and then you try and do more. Then you find the right questions where there's, where you feel that there's recent ideas of giving you a place to push. But then what happens is that there's this rising tide, right? All these other people around the world are also pushing, and things keep going. And so, when you have time, you keep going with them, and the tide rises and you rise with it. And then things happen and life gets in the way, and you get promoted and you end up on committees and you start doing teaching, and you've got family commitments, and you can't spend 12 hours a day doing mathematics every day because it's just not practical. And then you become more strategic in what you read, but ultimately you can say that everything washes over. This is what happened to me, at least. Things wash over you, and now suddenly you're not at the forefront anymore. And you attempt to, you go to conferences and you get little snapshots. It's like, I'm up here, I'm up here, I'm up here, I'm up here. And then, so then you're scrabbling you get some kind of feeling but your understanding is far less profound of everything. Because this is what happened to me. Maybe some people are just effortlessly swimming and staying ahead. And after a while, I realized I was drowning. And this was somewhere when I changed area and decided that actually now there's almost no point working super hard to get back, to get back to the top and to keep pushing. And maybe it was time to change area and instead try and make a computer. Yeah, of course. Try and make a computer that can swim to the top instead of me. But that was what happened to me. Mathematics just keeps going, inexorable progress just goes on and on and on. And there are times in your life, when you're lucky enough to be, right there with everybody else, building away, pushing mathematics further. The boundary of that, there's the Platonic universe, and then there's the known universe, which is a different thing. There's everything that's true, and there's everything that we know. Yeah. And so, somehow at some points in my life, I've been at the forefront of where we know.
And that's amazing. That must be very exhilarating. I guess that.
It's great. I mean, if you're into that kind of thing, I mean, there might not be any applications, but on the other hand, you have a panoramic view. There's some small part of the Platonic universe where you and your friends are the masters.
Wow.
It's like great.
That's amazing.
Wow,
that's amazing, huh?
It's a very cool thing.
Jesus Christ! Like, what more can you dream of? I mean,
that's not everyone's idea of fun.
Yeah. People are
but for me, it was super exciting. It's like we're making the P.H. Langlands program, and here I am, and I'm one of those people making it, and I know exactly. We're trying to work out what the conjectures are. We're at that point. There's this new theory emerging. We don't even know what the right questions are. We're struggling around in the dark, and then you meet with these experts, and you see some ideas and some lights come on. It's like, okay, now we have a better picture of what's going on. Yeah, it was a crazy
That's amazing.
time.
That sounds, and I guess it's a classic question of not to be glass half full type of person, but it sounds like a classic question of once you've been on top of the world, it makes for a very strange descent. So because once you've kind of been at the forefront of everything, and you are, literally envisioning. You're standing on whatever
the shoulders of giants.
Shoulders of giants. It's almost like you're out there venturing in sea on this great pirate ship, and you're going where no one has ever ventured before, and everything is just wow.
Yeah.
That's and then having to go back and go crap, and then
potentially more people are going, right? And this is that I always regarded these people as my friends as well. This is my model of what was. The social aspects of it.
Yeah, of course.
We were all venturing out together. I never saw it as a competition.
That's amazing. Even that, you're right. Even that is amazing. That it's like brothers in arms almost, kind of on a shared collective mission to kind of explore the great unknown. It's, it's genuinely beautiful. But then the glass half full is indeed the descent here. Because the one thing is just going, okay, I'm going to take a break, right? I'm going to take the ship back, turn it around. We're going to dock, and I'm going to be here. And I guess for you, I had my first kid. He turned 1 year like 2 weeks ago.
Fabulous.
Thank you very much.
Congratulations.
Thank you very much. And so that's one kid, but you have 3 kids. So I would imagine, because I actually genuinely curious about that transition for you of going, PhD student, you basically, I don't know if you live here, right? But like that's the thing that exists is math. And that's what we're doing. To now there's kids and responsibilities, and I suppose there's also the other thing you mentioned where it seems as if, speaking from the few professors I know, once you achieve success in academia, it's very easy to now have a bunch of administrative stuff and grant proposal, and you need to hire people and boards, and I don't want to make those things necessarily sound boring, but they at least take away from the thing that you wanted to do to begin with.
Yeah, I manage mathematicians now, and that means I have less time to do mathematics, but I've got plenty of time to get other people to do mathematics for me. Right?
Which I guess is kind of the equivalent then would be you kind of go back, you dock, you sit there, and now you try to go back, and you are still at sea, but you know that you're not at the forefront. You're not at the edges of the ocean anymore.
Yeah.
But you manage people that you try to send to the edges of the ocean almost. You're essentially, and that transition, even just from an identity perspective, has that been difficult to do? Because it feels like you're kind of remodeling like parts of the meaning of your life to some extent.
I do. I want to know, I want to see progress. I don't want to see me making progress. I want to see progress. That's how it is for me, right? Maybe that's not how it is for everyone. But I want to see progress. And so, this is why I'm so interested in computers at the minute, because I think computers have got an opportunity to make progress. Right now it's not the case. Right now, language models are writing mathematics that isn't correct. You put a language model at the boundary, and you say, now go ahead and go with them. And it's just like, sure.
It's going to start diving. It's going to go.
I can just write the kind of things that these humans write, because I've read all their papers, and it can attempt to write, and it's like not always correct. And, at the minute things are kind of ropey, but I think things will get better. So I'm sitting around at home, my pipe and my slippers, but I want to I'm trying to make a machine that can do that instead. Yeah. This, one of my current hobbies is, and it's just, things changed, But my brain is older, right?
Yeah, of course.
And maybe I'm not suited to. You adapt, right? Football players do this, right? They're young and they run around.
Yeah.
And then as they get older, they have to adapt. They change their game. They adapt to their. They can. They have insights, but they're maybe not as physically fit because they're older. And if they're really smart, they can adapt and still be brilliant. But in different ways.
Yeah, no, absolutely. It's a bit too bad. Is there? No, I don't think there's a mathematical equivalent to. You're right. There's the aging soccer player. I get that. There's a mathematical equivalent. I don't think there's a equivalent to the retired soccer player. That identity crisis is crazy to me. Because I guess there's not, like, mathematicians are lifetime, no? Like, when you are, Russell died at, like, 97 or something insane. So I guess it's a lifetime endeavor. You don't ever have to, you just, not said lightly, is you have to adapt to whatever the circumstances are, whether it's time or it's okay, then mental faculties, notice any type of difference? Is there a difference between 20-year-old, 30-year-old, 40-year-old Kevin, etc.? Or do you feel as strong and as cognitively present as you always had?
No, in common with essentially all of my friends, I'm now more forgetful than I was.
Interesting.
I emailed my advisor recently, like literally a week or so ago, and asked him a question. And I just had this sort of nagging, I don't know, there was something I couldn't let go about this question. I emailed my advisor, and then 6 hours later, I was plowing through old emails that I'd sent to my advisor, and I found that actually, literally 6 months ago, I'd emailed my advisor with the same question. And so then I emailed them back saying, actually, yeah, sorry, I asked you that already. You answered, it's good. So you see, that I would never have done that when I was in my 20s. They would have told me, and it would have fitted into it. I asked a question, they answered it. It fitted into my worldview adapted. Okay, that's great. And then something fell off, right? And suddenly, and then I'm like, oh yeah, this is an interesting question. I must have gone through the same thought. Oh, here's an interesting question. I don't know how to do it. Let's ask my advisor, because my advisor's a brilliant man. So that's something that wasn't there before. People told me something once and it would stick.
Yeah.
So now I have to be, when I learn things now, I need to write them down, right? Carefully. This is the thing. There are times in my life when I'm very busy because I get gigs. So I sort of travel around.
Yep.
And you work stuff out on an aeroplane and you don't write it down because you're just like, you've got to go and catch a train or whatever. And then maybe it goes. I don't think that happened before.
Oh, wow.
So I've had to, I need to be more careful. Maybe I should slow down. I need to write down more what I'm doing. And also I write stuff and then I reread it and I learn from it. Because it went in, it made sense, I understood it, I forgot it. Yeah. I then reread it and I learn it again. So there are advantages now. You see, I'm learning to adapt my game. I'm learning to carefully document what I understand, and I'm currently going through a big period of doing that. Now I'm currently trying to I'm trying to do a thing, and right now, I'm trying to understand an idea, and the way I'm understanding that idea is that I decided to give 16 hours of lectures on it. Oh, interesting. Because the way you understand things properly is by teaching them.
Yeah,
right? This is one of the things I've learned. I wasn't doing that in my 30s. I was understanding them in a completely different way. But now, good way of so I teach them and I write really good and careful lecture notes, some of which I don't even say, right? I write down details that I might not even have time to say. But I'm writing everything down and it's forcing me. It's really hard work. Most of my working life at the minute and up till the end of March will just be spent designing this course, including material that I might not even say to the students, but stuff that I need to get down on paper. Yeah. Because if I don't get it down on paper, then, as I say, it's going to be like what happened to me last week. 6 months down the line, it'll be gone. But in 6 months' time, I'm going to be able to look at these extensive course notes and say, yeah, okay, this is how it all goes. Yeah, of course. So I'm definitely adapting. That's as you get old, that will happen to everyone, I think, in their 50s.
Yeah, absolutely.
That's how it works. You start forgetting, and then you need to adapt. But I think I've figured out how to adapt.
Yeah, it's super impressive to. I mean, you're right. I think it's a natural thing because the alternative is also that you don't adapt and then think everything kind of goes sideways. So it makes sense that there's a. It's still very impressive to have that level of adaptation. Also because the adaptation is like it's centered like cognitively. It's your brain that you have to figure out how do I get my brain to still be able to do these things. It's which is a fun thing. And there's actually a point on the brain that I want to touch on, and it's oh my God, it's another quote I have somewhere. Yeah, all of them. I have all of them. But I think this is genuinely interesting. And I think it's interesting to see, is this just lore, right? Is this just people romanticizing stuff again? Or is there something to it? And I can't think of anybody much better equipped to answer this than you, especially considering how cognizant you are of, how do you keep performing? How do you keep staying sharp? How do you keep your ability to understand things and produce? So two quotes. I'm going to say who they are after the quotes, but they're about two different people and arguably two of the greatest of all time. And so the first quote is, his peculiar gift was the power of holding continuously in his mind a purely mental problem until he had seen straight through it. Anyone who's ever attempted pure scientific or philosophical thought knows how one can hold a problem momentarily in one's mind and apply all one's powers of concentration to piercing through it, and how it will dissolve and escape, and you find that what you are serving is a blank. I believe that person one here could hold a problem in his mind for hours and days and weeks until it surrendered to him its secret. So that's the first one. Second one about the second person is, his awesome mathematical talent was augmented by an ability to devote himself single-mindedly to any problem at hand in extraordinary periods of intense focused concentration. At such times, the more mundane concerns of life were simply ignored. We learn from Plutarch that person two would forget his food and neglect his person to that degree that when he was occasionally carried by absolute violence to bathe or have his body anointed, he used to trace geometrical figures in the ashes of the fire and diagrams in the oil on his body, being in a state of entire preoccupation and, in the truest sense, divine possession with his love and delight in science. So person one is Newton. Person two is Archimedes, so arguably completely, the greatest ever. And it seems like they kind of align on the same idea, which is his ability to sit with a problem for extended periods of time. And you just...
Maybe they were autistic.
Could be. Yeah, it could. I mean, I'll say the second one where he goes, he's diagrams on the oil lamp. I'm imagining some guy just being forced to shower and he's sitting there trying to draw. That does seem like it deviates a bit.
That's lots of people.
Yeah.
Yeah. That describes many mathematicians, I suspect.
That's so interesting. How pivotal do you think this ability is for a mathematician? And do you think
this is certainly something I recognize in my younger self?
Oh wow!
When I was a postdoc, I became nocturnal as a postdoc.
Whoa!
Because I found that I could get stuff done much better if people weren't bothering me.
I like that.
So I would go to work at 5 p.m.
Ah.
And work until 9 a.m. And
that's interesting. And you didn't do that because there was just something intrinsic in those hours of the day were easier for you. It was more inspired by the fact of going, I need complete solitude. I need people to not be around me as I do this. That was the inspiration.
Yeah. And actually, it's not as smart as you think it might be, because what would happen... So I would work and work and work. And then I would realize that I was incredibly hungry.
And you sit there at 3 a.m. going, oh
no. Okay, so now I need to go and scavenge, and now I need to go and hunt. So then you go and find some late night place in Berkeley, where I was at the time, which is still serving pizza or whatever. And you're forced to stop working and leave your pencil and paper and go and eat. And then during that process, when you're away, your brain isn't stopping, right? Yeah. You're still thinking about the question. You're just thinking about it in different ways. And often during those times, I would think, why am I even thinking about what I was doing? It's never going to work. It's you're doing the wrong thing. If it's really important to take a break, because then you start mulling things over in a different way. And you're like, I've ended up doing a calculation that I was convinced is important, but now I see can't be important. And I should go and do something else. So then you're fed, and then you go back and you switch the coffee machine on, and you start again on something else. But you're still working on the problem. I'm not going to let go of that problem. So I think this is this might be true of lots of people. I don't want to let go. I want to get to the bottom of this. It is important. Yeah, now I develop techniques. Now I do stop. Yeah, because this is when I learned when I was a postdoc that actually just thinking constantly about something forever. It's important to shower, or eat, or whatever, or sleep, or something. Because that gives your brain time to chew on things in a different way. And I think I was guilty of overthinking at the time. Just, you've got this question, you have an idea, you have another idea, you have another idea. Now you're off doing something, you do a calculation. And in some sense, you've lost track. It's like you've got to something, you're still living in the Platonic world, digging away at this thing. But you've sort of haven't realized that actually you're probably digging in completely the wrong direction. You're still getting understanding, but it might not be helping. Do you want to expand or do you want to go forward? Right? There's two slightly different things, right? That's interesting. There's a direction you want to go, and then you can start digging, and then at some point you're just like, it's the joy of digging. It's like, I'm getting this. It's like, I'm making progress. I'm understanding more. But are you going in the right direction? That's a different question.
You can make like, oh my God, I'm moving so fast, but the direction is kind of skewed. It's a strange direction to even go in.
It is to have these. I was very good at these obsessions, and let's say I think that's probably because of my autism, and maybe these people were autistic too.
Yeah, interesting.
But it's not. It's definitely not the only thing. You need some broader. It's understanding is not just about digging.
Yeah, absolutely.
It's about digging in the right direction.
I like the idea of kind of stopping everything, and then I think I know like Nikola Tesla like famously walked. At least that's what he claimed. Walked like 15 kilometers every day. At least it was a very important thing for him to just walk and just have everything kind of absorb, simmer a little bit as he's tried to figure stuff out. So I agree with the thing of going constantly sitting and thinking. Yeah, you need the breaks where you can kind of let everything digest and then feel. Maybe kind of going to something that are much more practical. How much time have you spent like thinking about how do you make the biological machine that is Kevin like efficient? I.e., poor night's sleep. Oh my God! Like even if you want to be absorbed with a question, it's like your body is fighting you. You eat a huge meal, you're just sluggish and tired, or all of that stuff. Has that been something you've ever been like consciously trying to solve, or has that always just been a side thought? If that,
I think I'm too much of a hedonist.
Yeah,
I just want to have I enjoy being in this world, right? Figuring out new things. I think there have been times in my life when I wanted to be top in exams. I was thinking a lot about being efficient. But I think when I became a researcher, I became more drawn into the idea of having fun. I enjoy my job, right?
Yeah.
And now I don't have to prove, I'm in a privileged position now, right? When I was younger, it was very important to keep publishing papers and, to get the job and to get the promotion and whatever, to try and get the prizes. But now I'm more interested in enjoying myself. And so I think maybe that's not true. I still have goals and I'm still well aware I need to achieve these goals. Maybe I just have a better understanding of where I'm going now. It's like at the minute I'm funded to do something. I've got 5 years of funding, of which 3.5 are left. And I've got to do that thing. And so I'm well aware that in 3.5 years, I need to know where I need. I know where I need to be in 3.5 years. And I do know, and I know how I'm going to get there. And so I guess I am constantly making sure that I'm going at the right speed. So there is something. Maybe I'm just better at managing.
Yeah, it could be.
Maybe when I was a postdoc, I was just, you've got to get where you're going, and there's various ways of solving it. And when you're a postdoc, a good way of solving it is observing that I'm in a different country, I have no friends, I have all the time in the world to do mathematics. And so I'll just do mathematics and I will get to where I'm going just because I'm doing mathematics a lot of the time. Whereas now I'm more conscious about the time I have. Yeah. And I guess I am going, sometimes I do stop. You're right. Sometimes I do stop because I realize I'm not working efficiently. and I think I should go and do other things and come back to this question. Like if I'm stuck, for example, right? If I was stuck in Berkeley, I probably wouldn't stop. I would just keep going. Whereas if I'm stuck now, it's just like, okay,
let's
it's
take
like, I've got other
breather.
things to do.
Yeah, absolutely.
I manage my work-life balance differently because I do want to work more efficiently.
Yeah, absolutely.
There you go. There you
Damn.
go. Maybe I'm growing up.
Oh
I
my
guess.
God. Oh no. Oh no. Oh no.
Oh, weird thought.
Do you, again, trivially, have any focus on stuff like diet or anything else, like the silly physical things of, like, is that something that you're conscious of, where you go, I try to eat this, or try to eat like during these times, or I try to exercise? I'm curious about exercise. It's always been weird for me to try to mentally, cognitively be very present, but not moved. It feels like those two things can't. I have to physically move my body in order for me to feel like I feel good up here. So like that stuff, like exercise, diet, all of that, like I'm going to call it trivial. I don't think it's trivial to some capacity because it's obviously secondary to what it is that you want to achieve. But yet without it, at least to me, it feels very difficult to do any like good work if I don't like biologically.
That's interesting. Because I didn't give a monkeys about this kind of thing at the time.
Wow.
I just did what I wanted.
Wow.
For a long time. But more recently, so my partner is a doctor.
Yeah.
She's very aware of these things. And now we eat very healthily and I go to the gym, things that I never did. Like 10 years ago, I wasn't going to the gym. And I'm conscious about my exercise and I'm conscious about my weight. And I again, this is an optimization that I didn't choose to for me, it was just all about the brain and like thinking about things and who cares about the physical body. I'm just in my Platonic universe, not too bothered about things. This is something that came to me later, the importance of
interesting.
Sort of
Crazy that
health.
It didn't like bleed over, that like the physical aspect. Maybe you were just doing like maybe you were just making right moves, like you were, maybe you were physically active and you were, walking a lot, moving, running, maybe whatever. Food-wise, a big culprit is you overeat too much food, like really knocks you out. So maybe you were just like unconsciously, in the same way that Archimedes kind of forgets about these ideas, and yet it still allows his mind to kind of work because it's, not that many calories can be good and exercise.
I think a lot of it is due to my partner, really.
Oh, wow.
Who's just been much more aware of these things.
Wow, amazing.
She in many aspects, she's the opposite from me. She's very aware of the real world. And when we had small kids, she was very conscious of feeding them excellent food. She was in charge of a lot of the food back then. Now I cook more. But at the time, she was really in charge of the diet. And the exercise just came from like just running around trying to keep 3 kids, The exercise came from just trying to keep the ship afloat then when you've got small kids. And now it doesn't, because now I've got big kids who can look after themselves. So that's why the gym, right?
Yeah.
But the healthy food, I was eating crap in my 20s and I got away with it because I just got away with it. But I think that probably she saved my life. I would imagine the fact that she was well aware that you couldn't keep eating crap and that actually at some point you have to get your act together.
Yeah, of course.
Start acting like a grown-up. I think she was well aware of that long before. Maybe I'm just becoming a grown-up now.
Yeah.
But I think the fact that I was living with somebody that was
that's amazing.
well aware of the importance.
That's amazing.
I think she probably saved me.
She's going to be very happy and excited when she listens to this clip.
I think she knows this.
She goes,
she's,
duh.
She's well aware of this fact already.
Yeah, it's not anything new.
I've eaten very healthy since we moved in. We moved in when she was 38 weeks pregnant.
Whoa.
With our first one.
What?
Yeah.
Wait, what?
We were just living.
You didn't live together up until she was 38 weeks?
Yeah. We moved in together when she was 38 weeks pregnant.
How long had you guys been together prior to that point?
33 and a third years. We just had a 33 and a third.
Whoa, that's crazy. Whoa.
Yeah.
That must have been an insane turnaround.
But we've been dating for like 8 years. We just lived in different countries or different cities. And
I'm thinking both in terms of, so one thing is moving in together. We'll always have like a period of, hey, we just gotta get used to each other's rhythms. Even if we've been together for like 10 years, it's still we just have to figure out how do you do this and I do that.
Right.
But then you add in a pregnancy that late.
No, we added in this baby.
Damn.
17 days after the baby was born, we moved to Paris. So we didn't know anybody. We could barely speak the language. And we had this 17-day-old baby.
Jesus.
And it was quite an adventure.
I can imagine.
We've had lots of adventures. But so if we had not been compatible, it would have been a catastrophe. But it turned out we were compatible.
That's amazing. Wow.
But one thing that one thing I cared about was being organized and making sure that like the bills were paid and that the regular things that you could do with an algorithm were the things that I was in charge of. And then the holistic things, so like I was quickly kicked off the shopping, right? We're like, we need food. Like, okay, that's great. So I'll just go and buy food. And I would just buy what I bought. Like, okay, so apparently this food is healthy. So I'll just buy exactly the same as last week because like that's what the algorithm says.
Yeah.
And after a while, she's like, your shopping is so boring. It's like, but
that's, you give me a task, I fulfill the task.
Right, exactly.
That's hilarious.
She's like, okay, you're never shopping again.
Yeah, let's switch tasks.
Exactly.
Switch structure.
But on the other hand, you can be in charge of, paying all the bills because they come in at regular intervals and you just understand how to manage periodic tasks that can be done by a machine.
Very nice way that you guys managed to kind of split the load in a way that kind of suits both of you. Right? It's almost like a project management almost. You have different profiles and you have to figure out.
But I would just always eat the same thing as well. I was just like, okay, I'll eat pasta with red sauce on top and that's fine. That's
interesting.
And I can just live on that for a decade. And she's like, okay, we're not doing that anymore.
That's interesting. What's your relationship with food? There's like if we kind of take the two opposites, one is food is life and food is enjoyment and, different flavors. That's what food is about. And the other one is the mechanical. Food is fuel. Give me boiled chicken. It's all good.
I'm absolutely on the food is fuel. I only eat because
you need it. Yeah. Whoa.
Yeah.
Crazy.
Whereas she will refuse to eat the same thing 2 days in a row, which for me is completely illogical.
Insane. Wow.
But for her, it's just like, this is not how things work.
Wow. It's always been like that, even since you were a kid? Like this.
No, I think maybe I work towards that. Wow. I've now achieved food nirvana. It's purely fuel, and I don't care about it.
That's crazy.
That's something I've strived towards.
That's an amazing.
I'm not interested in food, so I can be interested in other things instead. So I'm missing out on something. I have a poor sense of taste. This is the thing.
That's awesome.
I have a poor sense of smell.
Yeah.
Which I think leads to now a poor sense of taste. And that leads to just a general lack of interest in food.
Whoa. My assumption was the reason you could kind of put food in this position of going, it's a fuel source more than anything else, is because you saw it as essentially a constraint. So while you sacrifice the whatever thing food gives you, it gives you freedom of thought to not have to worry about food. You don't have what should I eat today?
No, there's no cognitive load there.
Exactly.
My partner takes on that cognitive load.
Okay.
Thank you very much. Thank you very much, Tamsin, for taking on that cognitive load.
That's good.
Right.
That's good.
And there is a balance. And so in return, I need to take on some other...
Yeah, of course. Cuts both ways. It's not purely one direction.
The food, we tried it my way and it was a catastrophe. So now...
What are we doing this week, Kevin? We're doing pasta with red sauce every single day.
That's breakfast. Right. I mean, I would give it. Yeah, when I was in charge of feeding the kids, so I don't care.
So this is delicious for me.
I've got the algorithm. This is I'm looking for algorithms. That's how math works. Yeah. You can solve problems with algorithms.
Yeah, of course.
And so I've got this problem feeding my kids. So I've got an algorithm. It's like make them pasta with red sauce.
It's hilarious.
Out of a jar.
Yeah.
Because the red sauce comes in a jar. It's like great. You heat it up, you cook the pasta, 10 minutes later we're eating.
It's so interesting.
And when we're done.
It's very interesting.
And apparently some people don't think like that.
Yeah, it's very interesting.
But I thought about that for years when I was feeding myself.
Yeah.
And it worked great.
Wow. Very, very fascinating that you have that approach. And maybe it kind of makes sense that it's at least this is what it feels like to me, that there's this is maybe taking a big step back, but like the natural progression of humans is that we always solve problems. This is the the point is not to find ourselves in a situation where we have no problems. The point is to find ourselves in situations where we have interesting problems. That's kind of what the entire thing is.
Yeah.
And so it's like, oh my God, I have to pay my bills. It's an annoying problem. So you find a solution, you get a job, and you go, oh, great, now I don't have that problem. Now what's the next thing, and the next thing, and the next thing? So in that sense, the more you can free yourself from what could be considered trivial problems of like food and whatever, the more you're free to pursue the frontiers of mathematics,
hedonistic pursuits, you say.
Yeah. If you can free yourself of the hedonistic pursuits of all of this short-term pleasure thing, but that's impressive.
No, but doing mathematics is my hedonistic.
Wow,
pursuit.
that's yours. Whoa.
Oh, absolutely.
Whoa, that's
absolutely.
interesting.
It's my major hedonistic pursuit.
I enjoy the silly question of going. I ask this generally often, and I actually get the same answer more or less all of the time, which is kind of interesting. But now I'll ask it to you. Let's see if I get the same answer here. It is if you ever played something like GTA or whatever, like video games, and you have like the infinite money glitch. You have the down, X, whatever. Suddenly you have like a trillion.
Yeah.
If that becomes real life, and Kevin has trillion, so Kevin has funding for everything he could ever want to do, there's nothing anymore, like completely pure whatever. Like, what does Kevin wake up and do? What happens?
Well, I just do what I'm doing now.
Crazy. Wow, that's nuts. Because most people say, I would travel, I would da, which to me is an expression that they're kind of trapped in this weird scenario of, I don't actually do what I want to do. I'm in this position because I kind of accepted that it is what it is and I can't do anything. But really, if I had freedom, I would do something else. No, so the fact that you answer that is amazing.
No, I mean, 8 years ago, I got addicted to a computer game, right? I was playing a lot of Zelda in my spare time. But then I found this other game, this like math game, Lean. And then this new Zelda came out and I didn't buy, like the first time in my life for like 20 odd years, where I didn't instantly go and buy the new Zelda game and complete it. Because I was just too addicted to this math game. And I often get addicted to things, like random stuff. I got addicted to dots and boxes at some point.
What?
A pencil and paper game.
Okay.
You draw lines and if you draw the fourth line in a square, you put your initial in the, it's like this. This is me playing dots and boxes.
Dots and boxes.
Yeah, I play it.
That's hilarious. So it's a two-person game. I guess it could be maybe more.
2-person game. I play it sort of live against all comers. We have some festival every summer at Imperial.
That's hilarious.
And I take on all comers and just beat them all. I lost the game this year. I'm still hurting about it. I lost once this year, but I play these like 7-year-old kids and just hammer them. So I got really interested in this. So I was playing it in my spare time, evenings and weekends, and learning the theory. Because people like John Conway and Berlekamp had developed a mathematical theory. And I learned this mathematical theory and then became extremely good at the game. And then I wrote a paper. And then I wrote a paper on the topic with this random undergraduate that I'd met on the internet. There's a high school kid that I'd never met. At some point, I was sort of the best in the world at this game. And then this random high school kid came along and this random person on the internet came along and started beating me. Oh, wow. And I was furious. But I was also spending a lot of time on the forums of the game talking about the mathematics of the game and how it worked. And then they started answering some of the mathematics questions that I was raising. And then they got in touch with me and said, okay, so we were both playing anonymously, right? They got in touch with me and said, in real life, I'm like a 16-year-old school kid and I need to do a project. In the Netherlands, the system is you do a project in your final year.
That's so crazy.
I want to do a project on this game, Dots and Boxes. Bro. And but my high school teacher won't let me do this project because they don't know anything about the game and they think it's too risky. And I said, okay, so in real life, I'm like a math professor and I supervise loads of students doing loads of projects. So I would happily supervise you doing a Dots and Boxes project.
Is so hilarious.
Yeah, it was quite funny. And then so we had to tell each other what our real names were.
That's hilarious.
And then we wrote, and I gave him some questions and he solved them. And then I solved some more and then we wrote them up as a paper. And I published this paper. And then computers started getting better at the game. And then I realized that people on the site were cheating, like using computers to play. And then I realized that actually it was only going to be a few years before computers could play perfectly. Yeah. And then there's no point playing on the site anymore. So then sort of the obsession, it peaked in me getting a paper and then it sort of died away. So, okay, so here's some stuff about dots and boxes that we worked out and that nobody else knows. Because I'd read all the literature. Yeah. And so there's my contribution to the area. And now I'm going to go back to number theory. That's going to be my obsession. But then when this computer game came along, it became this obsession. And my partner was just like, okay, Kevin's got a new obsession. That'll just like, it'll be what, he'll play it through. Sometimes these things only last for a few months, like, some dumb game on my phone. It's like, okay, here's this dumb game on my phone, and I'm just going to understand it and solve all the levels, and then write levels of my own, and then write a computer program that solves the levels, and then I have a complete, then I'll write, then I'll stick up a blog about it, and then I'll exit.
Interesting. So like
but this computer game, it was like, okay, this is the most fun thing ever. I'm going to keep playing this computer game at evenings and weekends. And then I'm going to start playing this computer game at work. And then I'm going to start telling the undergraduates about this computer game. And then I'm going to realize that actually, if I'm smart, there's going to be a way that I'm going to be able to turn it so that my job is to play this computer game. Because that's like the perfect job, right? You're obsessed with the computer game. And so that's somehow what happened. And now my job is to play a computer game. And like, I'm as just happy as it's possible to be.
Yeah, that's amazing. That's amazing. Okay, it then seems like whenever you get one of these fascinations with something, you get completely hooked. And it seems like you kind of do that until you get to a point where, probably the rough simplification here is you kind of complete the game. You go, okay, and now I'm the master of this. I've done it all. Computers can, whatever. And then now you finish the game. But maybe this is probably the best time, obviously, to segue into lean and interactive theorem provers and all of that. What does the version of completing the game here look like?
To make a machine that can do math better than humans.
It would have to be that, right?
Yeah, that's what the goal is right now. But to prove Fermat, to teach Lean to prove Fermat. Lean is autistic like me, right? This is one reason I love it. Like it's you're solving levels of a puzzle game, but I make the levels, right? There's two for single player puzzle. It's like Sudoku, right? There's two aspects to it. There's creating the levels and there's solving the levels, and there's an art to both, but it's different skills. You create some tricky level, or you solve. They're different things.
Yeah, absolutely.
So, Fermat's last theorem is a very, very, very difficult level in this game, but it is like Zelda, right? You can't just run at that level. You can't just start the game and run straight to the boss and try it with your crappy sword and your crappy equipment. You have to build up an armory. You have to be prepared. So I'm just spending a lot of time doing other levels. The prize for some of the levels is you get new tools, right? Yeah. You get upgrades. So I'm just slowly creating and solving more levels to give me upgrades that I'm going to use eventually to battle this final boss. And that's my vision of it. But every level is exciting. Because I say to the machine, okay, we're going to do this. And the machine's like, well, how are we going to do that? It's like, we're going to do it like that. It's like, okay, give me more details. Because I'm very smart in some sense. I understand all the rules of math. I know what can and can't be done. But I'm very dumb in another sense, is that I'm never going to have an idea. Right? Lean by itself doesn't have ideas. It's just going to say, now you tell me what to do next. And then I'll just say, yeah, that's valid.
Yeah, of course.
You teach me, and I'll make sure you never go wrong. I'll make sure you never teach me something wrong. So we have this student-teacher relationship where we develop a theory. I make the level, which is like, develop this theory. And then we solve or I make 100 levels. That's what the theory looks like, We have this new item. Yep. We need to understand this item. Here's 100 levels. And if you've done these 100 levels, then by this stage, you're really good at wielding that item. Yep. So we make this thing, and we solve the levels together with the computer just constantly saying, okay, so what do we do now? Eventually, when you're near the end, the computer says, well, what do we do now? And you say, actually, you can probably take it from here. And it's like, oh, you're absolutely right. I can do it from there. Now it was easy. So the computer does start to say, this is the software by itself, right? It will do things which are kind of very straightforward. If you sketch that, now we're going to do this, now we're going to do this, now we're going to do this, and I figure that you can fill in the details.
Interesting. Okay, but it can fill in the details.
But at a very, very basic level.
Okay.
But like with the advent of AI, we're now getting to the point where you can say, actually, now there are some much bigger jumps. But, humans know how to do that. Yep. So I think now you have access to, now we're not just using Lean by itself, we're using Lean plus some AI search tool. Yep. It's like now you just go and figure them out because you can find the answers on the internet. Yeah. And you can figure out, and you can write Lean, like 2 years ago, you couldn't write Lean code. Yeah. But now language models can write lean code.
Yeah.
So now you can start to leave bigger and bigger gaps.
Yeah.
So the process gets accelerating. So now it's this great Sudoku, right? You're doing a Sudoku. Okay, so like this is going to be a 1. That's great. And now the next bit is, so now none of these can be 1s, right? Everything in the same row, that can't be a 1. And like if you're doing this on your phone, it's like you can manually go through and say, you're not a 1, you're not a 1, you're not a 1.
Sure.
And you're just thinking, this is really, a machine could do this. And that's what AI is giving us. It's giving us machines that can do, you say, okay, this is a 1. And then you think about it, and AI can now be like, okay, so now actually those can't be 1s, and this can't be this, and this can't be.
Yep.
There's some basic deductions you can make.
Yep.
But like, actually now there are machines, you say, here's the starting grid, let's solve this. And the machine's like, yeah, I can solve that. Right? That's where we are with Sudoku.
Yeah.
It's like, you want to solve a Sudoku, you can just take a photo of that Sudoku and upload that to an app, right? And an app can just solve that completely. Yeah. So we're at the stage where now you can do Sudokus in 0 time. But with math, we're not at that stage yet. But we are starting to make bigger and bigger jumps. So like I've got to battle this final boss. I need a whole bunch of powerful tools. Yeah. And even making the tools is hard work. But okay, so I've got some rudimentary tool. And now I want to make a more interesting and subtle tool. And it's just getting to that point where AI can help you make that tool.
Yeah, absolutely. And just for me to understand here in terms of what the complexity / the limiting factor here is to making this thing explode, and I guess to your point, kind of proving from our / theorem, is it that you have to build the tools, and the tools are fundamentally all of the theorems that have already been proven.
And the definitions.
And the definitions, and they have to be written in Lean. They have to be written in a way that you can kind of import all of this stuff into Lean, so Lean can actually use it. So when you then solve the Sudoku, i.e. you now build a proof of something, you can take all of these theorems with their definitions, whatever, and you can deductively chain everything together, and then it'll go, I already have all of this stuff, so I know all of the stuff that you're referring to. Now I'll try to compile, which is basically me just, and it's not basically, but me checking all of these steps, and if everything is good, everybody's happy. But
some people are happy.
Some people, oh no, it didn't. But the complexity / the limiting factor, is that in the creating the tools? Is that creating the Sudokus? Is that to do from r / theorem? There's like so many insane, crazy things you have to build into Lean, and this is what humans have to do? Or is it that it's the application of the theorem / definitions that kind of chaining that together in Lean? Like, what's the complexity /
Yeah, it's a complicated question. And what's even more exciting is that the answer is currently changing quite quickly.
Whoa.
Is that the bottlenecks are in different places to where these at the beginning, the problem was that it's impossible, right? It's just too far away. In 2017, you say, okay, I want to prove Fermat's last theorem with the tools we have. It's just like the problems are immense.
Mountain too tall.
The mountain's too tall. But now we're at that point where there is a route there.
Cool.
It's sort of interesting to watch the theory evolve as around us.
Wow.
There is a route up there, but it's going to take a long time. So I'm doing this weird thing. We need to get Fermat's last theorem is this flag at the top of this mountain, right? And we need to walk up the mountain to get to this flag. But this because this is a virtual mountain and a virtual flag, all we need to do is to kind of create a path from the bottom to the top. And you don't need to start at the bottom and build all the way up. You can make chunks of this path wherever you like on the mountain. You can just step away and you say, okay, I'm going to make this path over here now because I know the route.
Yep.
But like the
okay, that kind of makes sense. If you know,
I need to walk the route.
That's kind of cool. Yeah.
So I can choose where I'm going to walk, and I've got this 5-year grant, and I spent the first year of this grant walking from the bottom up to some, to some base camp 1. But I somehow got bored doing it. It was fun and exciting, and it needed to be done, but I lost interest in it after a while. So what I'm doing right now is I started at the very, very top, and I'm just building downwards in this way that people don't normally do mathematics. Amazing. Because I know the path I'm going to take, so I'm just like, let's do the stuff at the top because that's the most of course, interesting, exciting mathematically.
Yeah, of course.
That was the stuff that historically happened
Yep.
the latest. So now we're building stuff at the top. And part of the problem when you're at the very top is that to make some moves, you need some very, very difficult tools. And we don't have those tools yet. And to actually make the tools, to complete the tools so they're really actually there and usable and everything is checked down to the axioms, would be a huge amount of work. So I'm just making I'm making tools that they don't work in some sense. You say, here's the tool and here's what it does, and that's great. And now we've got that tool. I've just stated, here's what the tool does. It does this and it does this and it does this. Okay. And then you can open the box and say, well, how does it do that? And the answer is, actually, we didn't. It doesn't do that, really.
Wow.
We just skip that part.
Yeah.
That's like a really complicated level.
Wow.
That's maybe even a multi-year research project to actually prove that this tool does do this thing. And you open the box and it's not there.
Wow.
But I'm just like, I don't care about that. I'm pretending I've got the tool and I'm just going to make that thing, right?
Wow.
And that you open that box and there's this secret. And that's just a gigantic road that needs to be traveled, but it's something that needs to be done. But I'm kind of thinking, actually, maybe AI in 2 years' time, maybe AI can just do that for me.
Absolutely.
If I write down exactly what this tool's supposed to do, I've got to prove these 5 theorems, right? And these 5 theorems, and the proof's in the literature, and it's 100 pages.
Yeah.
But I've stated the theorems. I've made the level. The level is made. Someone has to solve it.
Yeah.
Solving it will be a very long journey. But the amount of money that's pouring into AI and AI for science and AI to mathematics, it's like maybe tools are going to get, maybe I'm just going to be able to take a paper in 2 years' time, feed it into the machine, and the machine is going to come up with some incomprehensible piece of Lean code that I don't understand, but you run it and it says yes.
Yeah, of course.
And it's just like, okay, so I've got this tool now works. Like the light is actually on. Like I'm using this tool and there's this sort of warning sign on it going, by the way, this tool might not actually work, right? That's what so I'm at the top with these crazy tools that have got all these warning lights going off, going, by the way, this tool actually hasn't been checked to the axioms of mathematics.
Yeah, that's crazy.
So there is a risk that actually you're going to do something and there's going to be an explosion.
Yeah, of course.
Right? But professional mathematicians have looked at the things that I'm claiming this tool is doing, and they're like, yeah. This theorem from this paper says that this tool does this job.
Yes.
So in theory, we should be able to fix that. And now, of course, because something that won't happen, but could in theory happen, is that in 2 years' time, the AI gets really good. So now prove that this tool does this stuff. And it's just like plowing through the papers, like, error.
Yeah.
It's like, wait a minute, like there's this claim in this paper and this claim isn't true. Like that always happens, but you just fix it by saying, yeah, it's not quite true, but this variant is true.
Yeah, of course.
But if there's this unrepairable error, which won't happen, because humans have read the proof of Fermat's last theorem really carefully.
Yeah, because the only situation in which this thing does crash and burn is if the original kind of walkthrough of Fermat's last theorem apparently had an error in there that nobody found out. That's of course not going to be the case.
Super unlikely.
Yeah, of course.
But you can't sort of theoretically rule it out.
Yeah, of course. But yeah, this is cool. So I get the idea of saying, let me start at the summit and work my way down. Does work, but you're right. You're essentially building tools that don't actually work. Like you can state what they do. You can say exactly how they're going to work, but they don't work yet because they're not connected to.
Yeah, they're not connected to the axioms. There's a gap between the.
Yeah.
But you see, there's this huge community of people which is slowly building up, right? We're going up this mountain.
That's amazing.
They're building all kinds of paths from the ground. Some of which are really not going towards the top. They're just developing other areas. They're sort of going up other mountains, right? There's all kinds of challenges, but there's this unstoppable force, people, and now, more and more machine. We're going to have to work out how machines are going to fit into this, because machines write code that is sort of very poorly. It's not part of the reason that I'm interested in formalization is because it's an art. I was talking about mathematics earlier. You see the beauty in abstractions and the beauty in mathematics. Sometimes these tools can really not find the beautiful approach. It's like, okay, we've done this thing. This theorem is true. This tool does what it's supposed to do, but the proof is ghastly. It's far too long, and it doesn't do it in the correct, it's a proof, but it's not the proof from the book. Erdős had this idea that there was this book that contained all the best proofs, all the right proofs. And these AIs are very good at coming up with the wrong proofs right now. They don't find the right abstractions. So you say, okay, so you're right, you've checked that the tool does what it's supposed to do, but the thing is, it's a really dubious, this tool is now sort of, there's wires sticking out, and it's sort of, it works right now, but somebody updates Lean, and this thing might just break.
This thing's going to break. Okay, that's cool. That's kind of like an equivalency to, somebody writes, whether or not it's a piece of code or, obviously for me, it's like somebody writes a bunch of data transformation, like this long data transformation chain or whatever, and I look at it and I go, you could actually just simplify this to like 4 lines of whatever. Like this is the clean way to do it, and it's much more scalable, whatever. So that's the equivalent here. It's essentially you have like this kind of monster of a proof that kind of works right now, but it's clear that it's not. And I guess Erdős's idea is you have this idealized version of the proof. Like there's this perfect version of exactly what it could be.
Yeah.
Okay, that's interesting. And so the problem is AI gives you the monster.
Today
it gives you the Frankenstein. Okay.
Yeah, today. And I want, there's lots of reasons I want to prove Fermat's last theorem in Lean, but one of the reasons is I want to, at the end of the day, I want to write it as a regular paper and say, here's what the proof of Fermat's last theorem looks like in 2026. And doesn't it look beautiful? Like when you compare it to what Wiles did,
that's awesome.
Wiles found a route to the top, but there are some parts of it which are pretty gnarly. And it's just like 30 years later, we have much better. I'm arguing that in some sense we found a beautiful route. And I want to make it as beautiful as possible.
That's amazing.
And so, so it's sort of interesting. I can imagine that in a couple of years' time, progress will have been much further on than I'd conjectured. But parts of the route, it's like, that is the right way, but here's the wrong way. And at least, the box is ticked, but it sort of might fall apart at any moment. So, it will be interesting to see what happens.
Yeah, absolutely.
With the journey. But AI can accelerate today, right? AI can accelerate us, but it's only ticking some of the boxes, right? The question is, what's the ultimate goal? Do I want it to be, I sell it in lots of different ways. I sometimes say, is the proof definitely right? We're going to find that out, right? And that is true. Yeah. We will find it out. And the answer is, but I know what the answer is going to be. The answer is it's fine, right? That's going to be the answer. So at some point, a computer will say it's fine. But that's not what I really want is I want a machine that can plow forward and make new mathematics. And to make that machine, the machine has to understand what the big modern questions are. So it has to understand the theory of where we are now. And that's why I'm doing it, really. Because I don't just want the tick in the box, Fermat's last theorem is true. I need the tools, because we use the tools for other things. This is the motivation. I want to be able to do lots of modern number theory, not this dumb 30-year-old question that was like, it was done 30 years ago and everyone knows it's fine. We're making the tools, and the tools can go and do. We're going to be able to give AI the tools and say, what are you going to do with that now, AI?
Absolutely.
And I have no idea.
That's amazing.
The AI dreamers are just like, the moment AI has the tools, it can do anything. I'm saying, well, that might not be true. We might still need humans to guide the machines and how to work them.
But
absolutely. We need to make the tools, and this is part of the motivation.
Okay, that's cool. So if Fermat's last theorem is a summit, you're saying to get to that summit, we build a bunch of tools. But the tools are used for all kinds of other summits that are not this thing, but we need those tools to be developed. And then this kind of gives us the great opportunity to do that, because it's a pretty high summit, so we need some pretty advanced tools to be able to get there.
Yeah, it turns out that the statement is very, very simple, but it turns out that the proof we know uses lots of very sort of fashionable mathematics and fashionable tools, and tools that are still very much being used. If it was just this thing, there's this trick, and you do this trick, then this other trick, and now we understand the mileage of those tricks, and we understand exactly what they do, and that's kind of the end of it, then it would be a far less interesting project. Like, we're making tools that are absolutely being wielded by the top, the people that have now forged ahead of me, and I can't catch up to. It's like, okay, you've got these tools. I'm going to make an AI version. I'm going to make a digitized version of the tools you're using. And so maybe you can figure out how to use these new techniques. Yeah, maybe AI can help you, or maybe
Of course.
Because the problem with AI is like lean is not AI, right? Lean is just like formally verified versions of the tools. And AI, you ask AI knows all the tools, right? In human language. You say, explain to me how to prove this great theorem, and it will just say, oh, use this tool and that tool and that tool. Explain to me how these tools work, and it will just write something that may or may not be correct. And then you say, actually, often at research level, it's not correct. It's often at research level, it's mostly correct. You say, this is mostly good, but can I just pick up with you? You say this is true, and actually, how do you reconcile that with this fact? It's like, actually, you're absolutely right. When I said that was true, what I meant was this was false. And let me modify what I just said. AI is really ropey with research level mathematics. It's mostly good, and that's not good enough, right? In math, you just need everything to be dead perfect, right? So mostly good is not good, and lean won't let you do mostly good. Lean will only let you do
perfect on nothing at all.
So that's where we...
which I can get. Oh, frustrating, I guess, generally also with AI. But this is I don't necessarily want to touch on this because I think it is a trivial point, but it's when it's wrong that it doesn't tell you is very weird. It's weird to code, this doesn't seem right. Oh, you're absolutely correct. It's not right. Sorry, it was my mistake. This is weird. It's a strange thing where it's super provocative if it's something that I don't know deeply. Then if I'm trying to learn something and it gives me that, it's just... frustrating. Anyway, so it's just a quick rant.
I think people don't see at undergraduate level. It now is pretty much perfect. Not always, but really, it's very, very accurate now because it's seen so many of the questions. But at research level, it's by no means perfect.
Running into
and the question is, will it become perfect? Like, I'm not convinced it will do unless you wire it up. I think this is the dream. Really, you ask AI a math question and it goes thinking. And then a couple of minutes later, it says, "Okay, here's my answer. Oh, and by the way, I checked all this in Lean." Right. That's somehow.
Yeah, that's amazing. Okay, so the verification mechanism, similar to if I ask any of the language models to do any kind of operation like arithmetic or whatever, it essentially just spins up a Python program, runs it there, gives me the answer. But so it's not that the language model obviously is trying to put tokens together to kind of predict whatever the hell the next thing is. It just basically spins up, this is kind of what you need to do, runs the script.
It's not just the language model, it's the
exactly.
It's the external tools as well. Do you remember at the very beginning, in 2022, you asked ChatGPT to multiply two 10-digit numbers together? And it would just literally make up, it would just give you an answer, and then you check it on a calculator. You're like, wait, that's not the right answer. It's like, oh, you're absolutely right. It's in fact this. And it was like the first digits were right, and the last digits were right, and the middle digits were just all made up. But now, in 2023, you ask it, it's like, let me just do that in Python. So I just want to see that change.
That's awesome. The same equivalent, but just Lean is for mathematical.
Or something that's verifying things down to the axioms. But Lean seems to be the most... Lean is the one with the most robust mathematics library, doing mathematics the way mathematicians do.
That's an amazing...
my bet is that if they're going to use any of this software, then
it's going to be Lean. That's an amazing partnership between kind of AI and then how does it bridge into this mathematical realm without going constantly into the oops type of idea. That's amazing. What about a little bit of a crackhead question? Supposing the dream comes true, a nightmare for some, I don't know. AI becomes amazing at math, it does all of it, and then human mathematicians become obsolete. Would you still recommend people? Maybe, I say still, I'm assuming you would recommend people learn mathematics even now, but I don't know if that's actually true. But would you recommend people to learn mathematics if the role of the mathematician is obsolete?
Well, people still play chess, right?
There you go.
Computers are... But no, I think a more reasonable answer, I mean, you could say chess is a hobby in some sense for most people. But I think for a long time, even if AI does get really good at math, then the best teams will be AI-human collaborations. I think that... let's assume that it has happened, that AI gets... Right? Some people would say the data we have doesn't even predict that AI is going to get really good at research level math. But let's assume for the sake of argument that AI does get good at research level math. Then I don't think it's going to take over, at least not at the beginning. Right? Before it takes over, it's certainly going to start helping us. And at the minute, it's not entirely clear. It's quite a ropey research tool. This is my experience anyway. Because it's really not, it's very rare that it's just 100% nailed on. If you ask it the right question, it's like that. So it's still not even accurate. And I think it will get to the point where mathematicians will start saying, yes, this is definitely helping me.
Yeah.
That the ones that are not the free stuff, but the people that start paying money for language models, they might get to that point where, okay, actually this stuff is good. I'm now collaborating with this tool. And I think that collaboration period might last quite some time.
Yeah.
I'm not sure that these things are going to take over. Because humans and computers just offer, I mean, the computer might be writing down mathematics in the way that humans write it. But the way that the computer is thinking about mathematics, if it's thinking at all, it's just thinking in a completely different way. So it's offering a different dimension of intelligence. And I don't think it's replacing the human. I think it's doing something else. So I think it will be human-computer collaborations will be assuming that the computers do get good. And then when does it get to the point where the computers are taking over? That might not happen for a while. But you see, this is the other thing. I'm 57 years old, right? And I just see it as retirement. Right? If these things take over, I just retire. But I'm not, in reality, I think that they become helpers first. And right now, you can find mathematicians say, I've written this paper and AI played an integral role. But 99.9% of papers do not have that property. Yeah. And I think it will be a while before it's more than zero. Is it even 0.1% of papers? I'm not sure. Yeah, we have to wait. Yeah. We have to wait till there's evidence.
Yeah.
And when that evidence comes, it will still be a collaboration.
Yeah. I think the collaborative nature makes all the sense. It's still something that has to guide and set a direction for whatever you want. Back to your direction, you can kind of go and make progress in this specific direction, but
that's the other thing, right? What's math about? Is it just about proving all the theorems? Right? It's not. Like math is about understanding. Yeah. So there's as I say, when I was on the forefront of the P-adic Langlands program, one of the big questions was, what is the question? It wasn't just, say we've got some machine where you type the level into Lean, right? You've got this level, you can state the theorem, it's like, now AI go prove the theorem, and you come back and a week later it's proved the theorem. Maybe with this incomprehensible proof that you don't understand. Okay, great. But if you're at the point where you don't know what the theorem is, then you can't. I think that's harder, working out what the question is. And I can believe that we can have a tool that can solve the levels. And also you can have a tool that sets really crappy levels, right? The art of a good puzzle game isn't just to make a level. It's to make a level that's sort of challenging and interesting and, difficult in the right way, not boring. So, and I think, there's a different kind of artistic process there. So I think it will be a while before we have machines that can make good mathematical conjectures. I've seen the state of the art currently is terrible. For proving theorems, things are getting better. Yeah. But for machines making conjectures, horrible. The state of the art is abysmal. Yeah. Every one I've seen is either trivially true, trivially false, or trivially equivalent to a known conjecture, or just boring. This is the problem. They're not making the right insightful leaps yet. And that's because they're trained on the internet, right? They're trained on some knowledge of human literature. So if you can solve a problem using techniques in the literature, then AI might have a good go at it. But if this involves a new idea that isn't in the literature, now you're out of distribution. Yeah. And so, and then performance can be radically different when you're out of distribution. This is exactly, you ask an AI a question it's seen before, it will give you the answer. Like, that's what they're really good at. And you ask it to come up with some conjectures that it's never seen before, who knows what's going to happen. Yeah. It's difficult to train them. To train a machine, it's like, we need a nice big data set. Like, here's 10,000 interesting questions, and here's 10,000 terrible, really boring questions. Okay, now go make more interesting questions. But that data set doesn't really exist. Yeah. Because I don't know.
Yeah, no, it makes total sense. There is a weird idea, and I guess this is also kind of going into, I know one of the big problems with AI right now is like the lack of continual learning. It's like the classic case is you hire somebody and they're an idiot for the first couple of months, but they kind of get it. And suddenly after like 6 months, oh my God, like they're actually making value. You just can't do that with language models efficiently.
Now.
Exactly.
Not right now.
So that would probably be the same type of constraint where it's like good conjecturing seems to be the ability to kind of look a little bit past whatever you have now and into the future and go which direction is interesting. And if there's no aspect of continual learning, of picking up from these things and kind of generalizing across of that, then it seems like you're right. Probably trivially true, trivially false to some extent. It's probably what the output is going to be. That's kind of interesting. But supposing they get to this point where they can create conjectures that are way more interesting than humans could do, do you still think there's value? Kind of going back to Darwin's sixth sense.
You can just ask this about any, maybe can AI can maybe do anything, right?
But the question
is this a question about mathematics, or is this really a question about anything?
I guess it's still strictly supposing that there is the 100 years from now, whatever the timeline is going to be, and humans are obsolete in every capacity. Like, there's nothing you as a human being need to do, and you could consider that to be complete freedom, right?
Yeah,
do whatever the hell you
Zelda
want.
again.
Yeah. Exactly. Would you then go, you know what, I think for human beings to have, but then we actually get into, let's take a huge step back, because I can see what is the fundamental assumption I'm running into here. The fundamental assumption I'm running into here is, of course, like, what the hell is the meaning of anything? Like, what's the meaning of, I can't say, you should learn math. Why? Because it'll make you smarter. Why do I give a shit about that?
No,
because
it's understanding.
And then, understanding. But then it's also, why do I care about understanding? That would be maybe if it's too
intellectually stimulating.
But then you would go, okay, why do I care about that? I guess the point comes down to, is the purpose of my life to be happy? And if the purpose of my life is to be happy, and I feel like I'm happy playing Zelda all day, then intellectual stimulation doesn't really seem conducive to the fundamental goal of just being happy if Zelda fulfills that greater than that.
For me, Zelda, I mean, there's fighting, but there's puzzle, at least somehow the earlier, I mean, things are changing in the Zelda universe. But for me, the excitement of Zelda was that there are often very difficult puzzles that sometimes you have to solve using ingenuity. But like, once you solve those puzzles, they're solved. It's like, there's this thing, you kind of want to get up there, you don't know how to get up there, but you can see something, but you don't understand there's something. And like, you're just not ready to solve that problem yet. And then you're doing something somewhere completely different, and you get some tool, and then at some point you have this realization that tool is exactly what you need to solve this problem. And then you go back and you use the tool and you solve the problem, and you've got that thing and you're in this new place. And that's kind of great, and you've made progress. But now that's done, right? Yeah. And you play the game, and eventually you get to the point where you've solved all the problems, and then you never play the game. If you're me, you typically might never play the game again. And then you don't play Zelda for a while, and then a new Zelda game comes out, and then you start. So with mathematics, there's still lots of learning. I can't just play Zelda forever because I'll run out of Zelda. Yeah. Which you don't run out of math, right?
Yeah, true. Yeah.
So I want to. You can keep going with the math because there's always more things to.
What about then, if we try to get at the silly question of what the hell is the meaning of life, and what's the meaning of life for a mathematician?
Oh, for a human, I think it's to have fun.
Yeah.
Oh yeah, but like without messing up other people, like respect for other people, and then within those boundaries, just have as much fun as possible.
Interesting.
I mean, that's just my outlook.
Yeah.
But that's how I live my life. I can't have fun at the expense of other people.
Of course.
But I can, if playing computer games brings me joy, and like proving Fermat's last theorem brings me. I mean, I know it's been proved already.
Yeah, but proving it.
But proving it in a weird, beautiful new way.
Yeah, absolutely.
That fills me with excitement.
Interesting.
And so I'm just having fun.
What about then going completely pivoting away from all of the math, more or less, and going into, because it does genuinely seem like you kind of get to do what you want every day, and you have fun.
I do.
Yeah, exactly. It really does feel like, even speaking to you, like the.
But I'm playing life on easy mode. Right? That's
But you've managed to
white male.
Sure, whatever. To some extent, I'll buy into that, but I still think it's one of those. ask anybody who's 20 and go figure out how do you make your life in such a way that you get to kind of play Zelda, or in this case, you can kind of get to ride lean for fun every day, and that's your job. That's a very difficult thing, I still think, to do.
So I'm extremely lucky.
Or you're very competent in kind of achieving that. But I love the humility. But so it does really seem like you have a ton of energy that I don't see from people who are in a oh crap, it's Monday type of situation.
Yeah.
But then the next thing kind of goes, seeing as you genuinely have fun and you enjoy what you spend your life on, do you ever think about the end? Do you ever think about mortality, that you do this and then curtains?
Yeah, that's fine. I've completely come to terms with my death.
Wow.
Yeah, it's
Can you walk me through that process? Like, did you have a point previously in your life where the idea of death was not what it is today?
I don't think I thought about it for a long time.
Oh,
but then
wow.
then you get all the people in the generation above me are dying now, right? And so now it makes it. My father's dead, and my partner's mother's dead, and uncles and aunts are all sort of dropping like flies. And you're just like, oh, okay, so I get it. So like, I was a kid, and now I've got, I remember being in my 20s, and now my kids are in my 20s.
Wow.
And so there I'm that generation up. And then the next generation up, you just kind of like, something bad happens and you die. And it's just like, but I've had far more fun in my life than I deserve to have. If I went tomorrow, I'd be like, I've got to be careful saying this because my partner says I'm not allowed to do that. There's still a very important role that I have to play in life, apparently. Like things like bringing up my children.
Of course.
And, being helpful.
That's crazy.
But I wouldn't be remotely bothered if I died tomorrow.
Wow. So no fear of death?
No, none at all.
Wow.
I would say I'd lived the perfect, from a purely selfish perspective, not the perfect life at all from the point of view of contributing to society. Obviously, the longer I live, the more I can contribute to society.
Yeah, of course.
But in terms of personal satisfaction and hedonism, I've just...
You had your fair share.
Oh, yeah. Wow. And it's not just like, there was that period in my life when I was happy, or there was that period in my life when I was having loads of fun. That's just like, that's the life I'm living now. Yeah, I love waking up on Saturday morning because it's the weekend. And I get to hang out with my family. And I love waking up on Monday morning because I get to go and prove Fermat's last theorem. It's just like...
That's great. But is there not a part of you that kind of goes, wow... Because I think that's like the ultimate, that to me would feel like that's the ultimate part of going, holy crap, I'm scared of death because look at this amazing life I get to lead and it's going to stop.
No, it doesn't bother me at all.
Wow.
It's just going to stop.
Damn.
There's the autism in me coming out again. I know it's going to stop. I've sort of completely come to terms with that. In fact, if it got to the point where I wasn't having fun, I think... You see, again, this is something I say that really upsets my family. Like, if it got to the point where I'm not having fun, then as far as I'm concerned, it could just stop tomorrow.
Wow.
And they're just like, no, you can't. Don't think like that.
That's an interesting...
It's like, well, it's not relevant now because I'm having a great deal of fun.
It becomes like a daily, Dad, are you okay, Dad? Because we got to make sure that you...
Dad is fine. Don't you worry about Dad.
No, that's amazing. I think it's a bit sad that there's a bit of stigma around that type of speaking of things in that way. I think there's the classic question from Camus on this, where he goes like, the most important question a human being can ask themselves is the question of suicide. It's like, why do you exist? Why do you live? And if you have no idea and every day is kind of then it's going to end anyways. Why not end it tomorrow effectively, right? So it just aligns up.
I can't comment on that because I know exactly why I exist.
Yeah, which is amazing. Yeah.
Yes. Wow. Because I'm surrounded by people I love.
And you get to play
lean
video games all day.
And I get to play my favorite game. Yeah, my job is to play a game that I love playing.
That's beautiful.
And I live in an amazing city that's sort of really interesting and fun. And,
that's amazing.
I got a text from my son at 7:45 last night saying, we've got a spare ticket for a random gig.
Yeah.
Yeah, we're going to see, I'm at this pub. There's this drone artist playing in an hour and a half. Do you want to come? I'm like, yeah, all right.
Yeah, vamos.
I'm suddenly out on a Monday night.
Yeah, it's amazing.
Watching Yellow Swans, a band who I'd never seen before, making this incredible ball of noise. I'm just thinking, this is, I'd come over, I'd stayed at the office till 7.
Wow.
I was doing something that I was really into.
Yeah.
And then I literally showed up at 8 o'clock I said hi to my partner. And said, by the way, I'm going out again.
And she goes, where are you going? I'm going.
I'm
listening to the
my
Yellow Swans. And she goes, who? And you go, I don't know either.
Yeah. You're going to watch some drone band.
It's amazing.
And they were absolutely phenomenal. It was a great show.
That's amazing.
So, yeah, I really cannot ask for any more. My life is full of interesting things.
Oh, my God.
Yeah,
that's amazing, Kevin. That really is. That's amazing. It's the fact that you've been able to kind of create this life for yourself and you live it with.
I'm extremely lucky.
Intention.
It's not amazing. I think a lot of people should be jealous. I just got dealt a lot of good cards, and you know
that's amazing. Normally
it's awful. It's luck.
Yeah.
I feel guilty that not everybody gets to live in this joyful way.
That's interesting. What do you think were the most pivotal moments then? What do you think? Or I guess there are two versions of luck. There's a luck which is I'm just born with certain, white male, whatever. And then there's the pivotal moments that kind of randomly by chance led me on a path that I clearly did not choose. I did not choose this path, but yet here I am in it. Like your father teaches people how to become math teachers, and so you have access to all of this amazing mathematical literature or whatever. Like how many of those pivotal moments do you think occurred in your life where you go, if this thing didn't, maybe it's like even meeting your partner, maybe that would also have been one of those.
And that was absolutely, it's the top one.
She's getting a lot of compliments today.
No, it's absolutely the top one. It's absolutely crucial part of everything. But then the autism, that turned out to be really helpful. It was the right kind of, autism was a very complex thing. Yeah. But this ability to just focus for a long time on abstract tasks.
Was it
turned out to be very helpful.
Was it difficult, like identity-wise, to think, crap, I'm different from others? You often see the thing of going, if you're different than others, especially kids growing up, will kind of go, everybody who's different than me, I kind of instantly react negatively almost. Like, kids can be kind of ruthless in
I had a terrible time at school. I wasn't always happy. I've just been happy from about the age of 18.
Whoa. That's crazy. So very impressive then that you've been able to kind of change this perception of, autism to, because I imagine when you're 18, if somebody asks, hey, Kevin, is this a blessing? You would go,
I was only diagnosed last year.
Really?
Yeah.
Wow.
But I was bullied at school. I had a terrible time at school.
Wow.
Just for being different.
Interesting.
It was a weird thing.
Oh, wow.
But somehow I went to university and I stopped being bullied because people were more mature and perhaps respected. I had a skill, right?
Yeah,
I was good at math.
Yeah.
And then I suddenly found myself surrounded by people that sort of had some respect for that skill.
Yeah.
And, I wasn't good at a lot of other things.
Yeah.
So, so it was like, I was good at memorizing what was in the top 40. but I was good at finding obscure music. But so from the age of 18, I think there's been a constant grin on my face.
Wow.
And random things. My partner, the kids, living in this city. I love this city.
Yeah.
And I love this job. Imperial gave me this job, and getting this job here. Yeah. That absolutely. Again, I got my job, and I've never left. Right. Wow. I got hired in 1998. Whoa. And here I am. 27 and a half years later. Wow. It's just like, this is good. This is perfect. Yeah. So why change? Yeah. They've treated me extremely well.
That's amazing.
And getting my job, finding my life partner, who it turned out was my life partner, and we moved in. We gambled and we won. All my wonderful children. I don't know. It's just
that's amazing.
Yeah,
that's amazing.
And
what about
Spotify? That's pretty handy.
That was pretty lucky as well.
Yeah, that's digitization of music, right? What was that all about? All that vinyl there that you can't see. Yeah. Hundreds of records that I now never listen to. Oh my God. Because if I want to listen to, there's an obscure full 10-inch there that I saw and I thought that'd be fun to listen to. It's like, great, it's on Spotify.
That's hilarious.
They digitized music. And we had the CD, and I remember this happening, like late 80s. It's like, what's the point of this? It costs more than vinyl, and it breaks. And they were like, oh, it's unbreakable. It's like, no, it just breaks in different ways. Like CDs jump, vinyl jumps, but CDs jump in a different way. And they're like, so this is progress, right? We've digitized music, and now it's just more expensive and differently good. Mm. But now we have, we have streaming services, and it's turned music on its head. Yeah. And this is my argument for mathematics. If we digitize music and amazing things happen, why don't we digitize mathematics? And then amazing things might happen to that. But at the time when I was saying that, I wasn't sure what the amazing things were. Yeah, of course. It turns out the amazing things are like language models and lean and things.
Yeah, of course.
But yeah, so there you go. Digitization of music, that was pivotal. But yeah, it means I can listen to Yellow Swans on the way to work.
Ah, lucky you.
Having
You don't have
seen
to
them live
purchase
yesterday,
that.
and it's like,
There's a vinyl called The Orb Assassin. I kind of feel
yeah.
compelled to listen to it. Yeah.
it's the Orb, yeah.
The Orb Assassin. That's a crazy name. All right, let me perhaps one of the closing questions here. This is just fun if there's anything here. If you can speak to, classic 20-year-old Kevin, 30-year-old Kevin, and kind of have a conversation, like, what are you talking about?
Oh, I just say things are going to be great.
Yeah, because it feels like that. I was about to ask,
Things
what
are gonna
advice would
continue
you
to be
give?
great.
But it feels like it's just you just enjoy. It's going to be great.
Yeah.
It's amazing.
Yeah, you're in for an amazing ride.
Oh, it's amazing.
Yeah, just good luck.
All right. Kevin, with that, we've been speaking for close to 2.5 hours. Yeah, it felt like 5 minutes, honestly. This was very strange. Almost like we were transported to the Matrix, whatever that means. Kevin, seriously, thank you so much. This was awesome. Yeah, I really, really appreciate it. This was really, really cool.
Okay, great.
Easy peasy. Vamos. Woo!